Muy buenas tardes a todos. Sean bienvenidos a este tercer día del primer coloquio Internacional, Aprendizaje y Enseñanza de las Geociencias. Le damos la bienvenida a todos nuestros ponentes, agradecemos su
Muy
presencia
buenas tardes a todos.
el día de hoy.
Bienvenidos a este tercer día del primer coloquio internacional Aprendizaje.
Y le damos la bienvenida a todos nuestros ponentes, disculpen, aquí cuestiones técnicas. Bienvenida a todos los ponentes y les agradecemos su presencia el día de hoy a esta tercera sesión del primer coloquio de aprendizaje y enseñanza de las geociencias. El día de hoy tenemos muchos trabajos enriquecedores. Les vamos a dar la bienvenida a nuestros primeros ponentes del día de hoy, no sin antes recordarles que tienen 15 minutos para su presentación. Veo que Valeria ya activó su camarita. Son 15 minutos de presentación y faltando unos 3 minutitos para que termine tu presentación, Valeria, te haré llegar a través del Zoom el aviso para que tú vayas cerrando tu presentación y si fuera necesario tendré que activar mi micrófono para interrumpirte unos segunditos para informarte para que tú vayas cerrando y después daremos paso a unos minutitos para algunas preguntas. ¿De acuerdo? Entonces, adelante, Valeria, con tu presentación. Gracias.
Disculpe, no me deja presentar, dice que no tengo autorización.
A ver, dame un segundito.
Ya, ya está habilitada. A ver, Valeria, ¿puedes volver a...?
Good afternoon. My name is Valeria Gomez Diaz, a high school student in Prepa 5 of UNAM in area 2 of Biological, Chemical, and Health Science. And I am going to talk to you about a topic that is of great interest to me, that is tectonic plates, mainly those in Mexico. I chose to research this topic and present it today because this is a topic that influences in our daily lives, but in the way in the geographic space and in the different phenomena that we frequently witness, such as the volcanoes and earthquakes. Every day the world trembles. In Mexico, there are tremors every day, and although most are imperceptible to us, they are there present, reminding us that our Earth is in a continuous movement and there are unstoppable. To begin with, we must remember what a tectonic plate is. Well, tectonic plates are large fragments of the Earth crust that are found in the continental masses and are in continuous movement. There are various theories regarding this displacement. For example, the theory of continental drift, proposed in 1912 by Alfred Wegener, who proposed the idea of a supercontinent that was named Pangaea. But because tectonic plates is a slow but constant displacement, colliding or rubbing each other, caused the fragmentation of Pangaea, giving rise to what we know today as continents. In additional movement of these plates give rise to the formation of different geological structures, like the volcanoes, mountain ranges, oceanic ridges, lava flows, and tectonic structures. Currently, there are 15 main plates in the world, also known as the major plates, and 43 minor plates or secondary plates. In the major plates, we can find the North American plate, Juan de Fuca, Pacific, Nazca, Cocos, Caribbean, South American, Scotia, Antarctic, Australian, Philippine, Eurasian, Indian, Arabian, and African plates. The 5 main tectonic plates in Mexico are Caribbean, Pacific, North American, Rivera, and Cocos. The North American plate covered most of the Mexican territory and all of the North American and part of the Atlantic Ocean and Asia. The Pacific plate is located in the Pacific Ocean and the Western California and Baja California. The Caribbean plate is found in the south of Chiapas, the Caribbean Islands, and the Central American countries. The Cocos and Rivera plates are located in the Pacific Ocean. The existence of 4 of these plates in Mexico gives rise to the Trans-Mexican volcanic belt, also known as the neovolcanic axis. Each plate moves at a different speed relative to each other. However, they have an average speed of 2.5 centimeters per year. The North American plate moves away at an approximate speed of 3.5 centimeters per year. So in about 10 million years, an island will form far from the continent, or some plates can move faster, such as the separation that occurs between the Pacific plate and the Rivera plate that moves at about 6 centimeters per year. The coast of areas of Jalisco, Colima, Michoacán, Guerrero, Oaxaca, and Chiapas are sinking because the Rivera and Cocos plate are sinking on the North American plate, which has caused various earthquakes. It can disappear in both. An example of this is that about 16 million of years above, in the territory Mexican, there are the Farallon plate, located between the Pacific and Cocos plate. It disappeared caused various biological structures, such as the San Andreas Fault. The remains of the Farallon plate are what we know today are the Juan de Fuca plate, the Cocos plate, and the Nazca plate. When two tectonic plates interact with each other, they can cause different types of boundaries, like the divergent, convergent, and transform. The tectonic plates move and interact with each other as a result of an internal process of the planet and can cause two natural phenomena, an earthquake or the birth of a volcano, as can occur when the molten magma is under great pressure in the cracks of the North American plate, causing it to rise to the surface, forming a volcano. The Gulf of California is another example of a formation result of these movements. However, as we mentioned above, tectonic plates are always in constant movement. The Cocos Plate is moving away to the east from the Pacific Plate. So in the Cocos Plate, due to its position, is forced to collide with the North American Plate, causing a under between them. Here we see a convergent boundary. The area where this place collide is marked by an area known as the Middle American Trench, which has a depth of 6,662 meters. As we have mentioned previously, tectonic plates give rise to the formation of fault mountains, which give rise to mountain ranges. For example, Sierra Madre Occidental, Sierra Madre Oriental, and Sierra Madre Meridional, which are found in Mexico, caused by the collision of the plates in the Mesozoic era, about 245 to 60 million years ago. In Mexico, the Cocos Plate undergoes a subduction. A subduction is when oceanic plates go under a continental plate. The Cocos Plate has certain particular characteristics. For example, the Cocos Plate is that for several kilometers inland and in central Mexico, it deviates deeply into the inner mantle, which causes earthquakes at intermediate or high depths. In Mexico, the largest earthquakes that have occurred in subduction zones.
Valeria, te quedan 2 minutitos, por favor.
The specialists on this topic are interested on the intraplate earthquakes, which are those that occur within the plates. As we have seen, tectonic plates move out all the time and continue to transform the Earth's crust, as they have done over thousands or millions of years, as we saw with Pangea, generating the different geological structures that we can find today, and are formed through the different movements of the plates. And through certain ways, we are aimed by these movements. It is something that we cannot change or avoid, because all this is part of the constant evolution to which we are subjected. In Mexico, the subject of tectonic plates is something that is very important to know, because as we have seen before, the tectonic plate is an inevitable phenomena that occur. Despite the technology and advance in research on tectonic plates, their movements cannot be stopped or predicted. All that remains is to know that it is something natural, that it happens to a reason, that they are not punishment from nature, but from nature itself. All that remains is to follow the civil protection protocols. like a backpack with some provisions. There are the references I use to do my work. Thank you very much for what this presentation, and it's all. Thank you.
Gracias a ti, Valeria Gómez Díaz, por tu presentación. Valeria, te comento y te pediría por favor que te mantengas conectada con nosotros. La sesión de preguntas hacia tu presentación la daremos más tarde, en otro bloque, por favor. Gracias, Valeria. Y bueno, ya está por aquí la doctora Janet. Vamos a dar paso a la presentación de la doctora. Gracias, doctora, por conectarse. El título de la ponencia es Explorando la vida en un ambiente extremo, extremófilos en el cráter volcánico Rincón de Parangueo, Guanajuato. Doctora, nada más recordarle nuevamente que tenía 15 minutos de presentación y le haré llegar a través del Zoom el recordatorio cuando falten 3 minutitos. Muchas gracias.
Sí, muchas
Adelante.
gracias. Primero que nada, una disculpa, estaba tratando de conectarme en otro link, pero bueno, ya estoy aquí.
No se preocupe.
Ok, creo que ya es posible que vean mi pantalla, ¿verdad?
Sí, así es.
Ok, bueno, entonces voy a comenzar. Yo les voy a hablar durante esta charla sobre un poco del trabajo que estuve realizando durante mi doctorado en la UNAM. Y bueno, el título de la charla es Comunidades microbianas y microbialitas en el lago cráter Rincón de Parangueo. Voy a comenzar hablando un poco de lo que son las microbialitas en un contexto muy general. El término microbialita proviene del griego micro, pequeño, bios, que significa vida, y litos, que significa roca. Por lo tanto, las microbialitas son estructuras órgano-sedimentarias que se han formado gracias a la actividad de comunidades microbianas, las cuales atrapan y fijan diferentes tipos de sedimento y producen la precipitación de minerales, lo que lleva a la formación de lo que nosotros podríamos llamar rocas. Aquí tenemos una imagen que nos muestra las microbialitas de Share Bay en Australia, que son unas de las microbialitas más populares a nivel mundial. Y como ustedes pueden ver, pues parecen rocas, ¿no? Pero en realidad son seres vivos produciendo estas grandes estructuras. Bueno, ustedes podrían preguntarse por qué las microbialitas son tan importantes, por qué es importante estudiarlas. Bueno, pues las microbialitas son la evidencia más antigua que se conoce en la Tierra. Tenemos registro de microbialitas fósiles de hace 3.500 millones de años y están ubicadas en Warragona, en Australia. También el estudio de las microbialitas nos ayuda a comprender los orígenes de la vida, también en el estudio de la astrobiología, y son una fuente muy importante de biotecnología. Bueno, aquí tenemos una imagen representativa de cómo era la Tierra hace 3.500 millones de años, y ustedes pueden ver las microbialitas aquí ubicadas en lo que son los mares primitivos. Ahora nosotros sabemos que los primeros oxigenadores de la Tierra fueron las cianobacterias, y las microbialitas son muy importantes porque las cianobacterias solían vivir principalmente formando este tipo de estructuras, por lo que al comienzo de lo que es la oxigenación de la Tierra, pues ellas tuvieron gran importancia. Esto permitió la evolución de formas de vida superiores en la cual estamos incluidos nosotros como seres humanos. Y bueno, en esta imagen tenemos una sección de microbialita fósil, y ustedes pueden ver esta laminación estratificada que comúnmente llamamos estromatolito, es decir, una microbialita laminar, como la que ven aquí. Y bueno, las diferentes comunidades empiezan a crecer desde aquí abajo, van precipitando los minerales, principalmente carbonatos. Una vez que los precipitan, forman esta capa. Luego las comunidades microbianas suben, principalmente para tomar luz, como es el caso de las cianobacterias, y vuelven a precipitar otra capa de carbonatos y así sucesivamente. Y bueno, en México tenemos algunos ejemplos muy populares, como son las microbialitas de Cuatro Ciénegas, las microbialitas de Laguna de Bacalar, las microbialitas en Achichica, Puebla, y por supuesto el lugar que yo estudié, que es Rincón de Parangueo, que está ubicado en el centro del país. Y además existen otros pocos ejemplos de microbialitas dentro de cráteres volcánicos, como lo son mi caso de estudio, que es una microbialitas que se desarrollan dentro de cráteres volcánicos. Tenemos además microbialitas desarrollándose en otras partes del mundo, como son en el cráter Navao en Tonga, el cráter Satonda en Indonesia, el cráter Anchichica en Puebla, que es muy similar al Rincón de Parangeo, y por supuesto el gran cráter de Yellowstone, donde hay microbialitas creciendo a 70 grados centígrados, y también microbialitas asociadas con actividad hidrotermal en el Rift de Kenia. Y bueno, ¿por qué es tan importante el estudio de ambientes extremos? Rincón de Parangeo es un ambiente extremo debido a que tiene una alta salinidad, alta alcalinidad, también intensa radiación solar, suministro de gases como metano y CO2 y en algunas ocasiones altas temperaturas. Bueno, existe un especial interés por la caracterización de los microorganismos extremófilos, principalmente creciendo en este tipo de ambientes, porque presentan lo que son condiciones que son retos para la mayoría de las formas de vida, pero para ellos es algo muy simple crecer ahí. Entonces son una fuente importante de conocimiento. Y bueno, como dato interesante, hasta el momento se tiene registro de aproximadamente 50 cráteres a nivel mundial con desarrollo de microbialitas. Entonces, Rincón de Parangeo es aún más importante porque solo tenemos hasta el momento 50 cráteres registrados con el desarrollo de estas microbialitas. Y bueno, aquí tenemos una imagen del cráter Rincón de Parangeo, una foto panorámica. Y bueno, aquí la principal característica del cráter, como ustedes pueden ver, es este color blanco. Em, es importante destacar que esta zona que ahora está cubierta de color blanco solía estar cubierta de agua. Desafortunadamente, la extracción de agua para el riego pues, de zonas agrícolas aledañas ha provocado lo que es el abatimiento del manto acuífero y por lo tanto, pues el lago se ha ido secando. Ahora solo tenemos unas pocas pozas remanentes que cambian de tamaño dependiendo de la temporada de seca o de lluvia. También importante mencionar que el color que ustedes aquí ven rojizo también varía. Algunas veces es marrón, otras veces es rojizo, otras veces es verde, dependiendo de las comunidades activas viviendo ahí. Y bueno, como les mencionaba, Rincón de Parangeo tiene una alta conductividad, lo que representa una salinidad casi 3 veces mayor a la salinidad normal del agua de mar, un pH alcalino y alta concentración de carbonatos, bicarbonatos y la formación de evaporitas como alita y trona, principalmente en las pozas remanentes. Y bueno, aquí tenemos lo que es el mapa de localización del cráter. Aquí ustedes pueden ver el color característico del Rincón de Parangeo. Y bueno, también tenemos algunos otros cráteres aledaños donde se han identificado microbialitas, como es el caso del cráter La Alberca, donde también hemos estudiado las microbialitas y sabemos hasta el momento que son diferente composición microbiana, pero estas microbialitas son mucho más pequeñas, no tan grandes como estas, y también algunos otros cráteres aledaños tienen tapetes microbianos, alguna que otra microbialita, pero nada tan extraordinario como Rincón de Parangeo. Y bueno, aquí tenemos un esquema de cómo es Rincón de Parangeo. Bueno, aquí tenemos principalmente las pozas hipersalinas que les comenté en la imagen panorámica. Estas pozas, aquí ustedes pueden ver el color en la época que tomamos la foto. Este es un tapete microbiano, que aquí está una muestra de mano de ese mismo tapete. Y si ustedes ven, tiene colores característicos de microorganismos, en este caso un color rojo asociado o rosa asociado con microorganismos halófilos, también un color verde. Y bueno, lo que hacen estos microorganismos es adherirse a las sales que se van precipitando con la evaporación y empiezan a formar ahí pues una comunidad que crece y ayuda a seguir construyendo el tapete. Bueno, aquí en el esquema también podemos ver en color verde, si ponemos atención aquí, en lo que es el perímetro del antiguo lago, tenemos estas manchitas verdes. Estas manchitas verdes es la cartografía que hicimos de las microbialitas. Aquí tengo una imagen representativa de una microbialita y bueno, a esta microbialita nosotros le llamamos estructura de coliflor, pues porque parece una coliflor, ¿no? Pero hay diferentes clasificaciones para las microbialitas, tanto macro, meso y microestructura. En este caso, la mesoestructura o estructura interior que se puede ver a simple ojo sería, como se puede ver en esta imagen, tenemos una estructura laminar o estromatolítica en la parte más superior de la microbialita. y en la parte interior una estructura dendrolítrica o una estructura de forma de árbol. Y bueno, esta diferente configuración de la estructura en la parte interna de la microbialita depende en gran medida de las condiciones al momento de la formación de la microbialita. Y bueno, ustedes estarán preguntando por qué las microbialitas principalmente están en esta zona, ¿no? Que les muestro en color verde. Hasta el momento, basados en los estudios que tenemos, sabemos que las microbialitas están creciendo más aquí en esta zona debido a que existe una falla que nosotros tenemos aquí coloreada en rojo, que es la falla principal del cráter. Tenemos otras estructuras o semifallas o fracturas que ustedes pueden ver aquí en negro. Y sabemos que están pasando un gran volumen de gases como CO2, metano, y estos gases lo que hacen es pasar por esta falla, llegar a la zona de las microbialitas y alimentar a los microorganismos. Es decir, los microorganismos que construyen las microbialitas están utilizando estos gases como fuente de energía y a su vez precipitan los minerales, en este caso carbonatos. Y bueno, basados en estudios de los gases y además también tenemos otras zonas que confirman la emanación de los gases, como son estas chimeneas hidrotermales, eh, que se construyen básicamente cuando fluidos pasan a través de una fractura, ¿no? Aquí tenemos en la imagen. También tenemos esta pared de falla que está impresionante. Aquí ustedes pueden ver la dimensión. Y este mineral básicamente es aragonita y se forma también por la precipitación de fluidos. Y bueno, les vamos a mostrar qué estudiamos en el cráter Rincón de Parangueo. En un principio el proyecto se realizó basados en la idea de corroborar si las microbialitas del Rincón de Parangueo estaban vivas. Como les mostré en la imagen, el tirante del agua llegaba pues hasta muy lejos, donde estaban las microbialitas, pero en el año 1980 pues empezó a desecar el lago, entonces cuando llegaron los geólogos a explorar la zona, vieron las microbialitas, ellos las ubicaron y dijeron, ah, bueno, esto está aquí, pero seguramente es una microbialita fósil. Entonces cuando este proyecto llegó a mis manos, la primera idea pues fue corroborar si estaban aún vivas, ¿no? Entonces lo que hicimos fue caracterizar diferentes zonas del cráter para ver pues qué había ahí, ¿no? Y bueno, aquí tenemos algunas imágenes de los muestreos que realizamos. Este es el muestreo en la zona de falla principal, donde recuerdan ustedes que está el perímetro del antiguo lago. Y bueno, aquí vemos un color verde característico de lo que viene siendo pues una comunidad microbiana. Además, tomamos muestras de agua, de las pozas remanentes en ese momento y de los tapetes microbianos. Y por último, tomamos sedimentos a diferentes profundidades. Por el momento, la profundidad mayor que hemos tomado es de 10 metros. Y bueno, lo que se hace es una serie de caracterizaciones fisicoquímicas y metanogénicas para identificar las principales comunidades que se encuentran en estos diferentes tipos de muestras y correlacionarlo con las características fisicoquímicas de cada sitio. Y bueno, esta es una imagen muy general de lo que nosotros hemos identificado. En este caso le estoy presentando bacteria y arquea y en último estudio estamos realizando lo que es eucaria, que también ha sido bastante impresionante lo que hemos identificado. Y bueno, algunas cosas importantes que quiero mencionar aquí es... primeramente tenemos, por ejemplo, aquí en la muestra 3, tenemos un no, bueno, desconocido, un gran número de secuencias, más de la mitad de las secuencias para la muestra de agua 3, que en ese momento era la poza más pequeña, con mayor salinidad. Tenemos un montón de secuencias no conocidas, es decir, nosotros no obtuvimos esas secuencias, pero no las pudimos comparar con las bases de datos porque no existen en las bases de datos. Eso nos está hablando de un gran número de secuencias o microorganismos que no se pueden identificar, no porque no estén en Rincón de Parangueo, sino porque muy posiblemente sean microorganismos endémicos. Entonces, esto abre la puerta a un gran número de investigaciones futuras. De hecho, ahorita ya se han publicado cierto número de microorganismos que ya se les ha puesto nombre y todo, y que son endémicos de Rincón de Parangueo y extremófilos. Bueno, también tenemos otros filos muy importantes, como lo son Nanoarqueota, Thermoplasmatota, Asgardarqueota, adarqueota, que son filos de microorganismos de arqueas, que son filos muy primitivos, es decir, se originaron muy al principio del origen de la Tierra y que han evolucionado, pero nosotros los hemos podido encontrar en el Rincón de Parangueo. Entonces nos está hablando pues de arqueas extremófilas que están en Rincón de Parangueo sobreviviendo a este ambiente tan extremo. Y por último tengo un NMDS, que es una gráfica simplemente para representar qué tan similares son las muestras entre sí. Y bueno, sabemos que las muestras de tapete son muy similares entre ellas, las de agua son muy similares entre ellas, etcétera. Y por último, tengo esta, simplemente para como resumir lo que está ocurriendo en Rincón de Parangueo. Sabemos que las secuencias, la mayoría de las secuencias que identificamos se encuentran dentro del dominio arquea, lo cual no nos pareció nada extraño por las condiciones físico-químicas extremas del cráter. Además, bacterias como cianobacteria, protobacteria, firmicutes, bacteroidetes, etcétera, fueron los más representativos en las muestras, lo que coincide con otras microbialitas identificadas a nivel mundial. Tenemos también en una alta abundancia la presencia de la llamada materia oscura, que en teoría podría representar microorganismos aún no desconocidos. Y bueno, esta última tabla básicamente son las especies indicadoras de nuestra área de estudio. Que también han sido identificadas en otras partes del mundo y bueno, están relacionadas con lagos hipersalinos, lagos alcalinos, chimeneas hidrotermales, otros tipos de volcanes, suelos salinos, es decir, existe, bueno, esta concordancia con lo que nosotros obtuvimos si lo comparamos con otras partes del mundo. Y bueno, esto sería todo. Muchísimas gracias por escucharme y bueno, estoy abierta a cualquier pregunta que tengan. Aquí dejo mi contacto por si alguien está interesado pues en que les comparta los artículos publicados a partir de mi trabajo de doctorado. Muchas gracias.
Muchas gracias, doctora Janet. Muy interesante su presentación y
Gracias.
definitivamente este estudio se ve que es muy amplio, requiere mucho trabajo, es un trabajo arduo. Por supuesto que tenemos preguntas para usted. Me voy a permitir leérselas. La
Ok.
primera sería, ¿cuáles son los conceptos y conocimientos básicos de que un estudiante requiere para comprender este tema tan interesante? Y ligado a,
Conceptos,
ajá, ¿qué
¿verdad?
debería saber un estudiante de bachillerato para poder estudiar este tema?
Bueno, como estudiante de bachillerato, yo creo que se comenzaría con lo que es la microbiología, definiendo qué es un dominio, es decir, arqueas, bacterias, eucarias. Después tal vez podríamos enfocarnos más en algunas definiciones de ADN, ARN. Luego podríamos pasarnos a investigar un poquito más de cómo son todos estos procesos geológicos, ¿no? Como qué es un volcán, cómo se forma un volcán, qué pasa después de que un volcán se forma. Y bueno, creo que sería bueno empezar por ahí.
Ok, muy bien. Yo le preguntaría al respecto, usted mencionaba que crecen en condiciones extremas. ¿Se ha descubierto qué es lo que les permite vivir justamente en esas condiciones tan extremas? Si tiene que ver
Sí.
con esta parte justamente de la secuenciación o algo así.
Bueno, lo que son los microorganismos, cada microorganismo tiene ciertas características particulares en cuanto a supervivencia, ¿no? Por ejemplo, tenemos las halófilas, que son microorganismos que secretan cierto tipo de proteínas que les permite sobrevivir a altas salinidades, es decir, que la salinidad no las, como por decirlo, no las...
¿Afecta?
ajá,
Mm.
em, y bueno, también hay un número de microorganismos que se ayudan de sus compañeros. Por ejemplo, en este caso, las microbialitas, se forma toda una cadena trófica en la que unos utilizan ciertos compuestos como fuente de energía, segregan otros compuestos que los que siguen van a utilizar como fuente de energía y entonces al final es una comunidad que está trabajando junta para sobrevivir. Muchos microorganismos lo que hacen es hemos identificado microorganismos que lo que hacen es meterse en los poros de los sedimentos para evitar la luz, mientras que otros como las cianobacterias buscan la luz. Entonces, las cianobacterias están ayudando a que los otros no les dé la luz, pero pues es como una cadenita, ¿no? Es como nosotros como humanos, realmente solos no podríamos sobrevivir, ¿no? Necesitamos la ayuda de nuestros compañeros de vida y de sociedad pues para funcionar adecuadamente, ¿no?
Wow, qué interesante saber que eso también ocurre, ¿no? A
Sí,
niveles que no imaginamos, ¿no? Qué
ujú,
interesante. Muchas
sí, sí,
gracias.
sí.
La siguiente pregunta sería, ¿qué métodos se usan para hacer estos estudios?
Bueno, si hablamos de métodos fisicoquímicos, nosotros hablaríamos de métodos de laboratorio donde nosotros utilizamos estos sedimentos o el agua, se les mide conductividades, se les mide pHs, densidades, métodos de granulometría para clasificar si es un suelo arenoso, un suelo arcilloso. También se ha identificado que depende del tipo de suelo que se encuentre, es el microorganismo que se va a adaptar mejor a vivir ahí. En cuanto a métodos más genéticos, extracciones de ADN, diferentes metodologías de extracciones de ADN como em, fenolcloroformo. Últimamente se está utilizando bastante lo que son kits de extracción, que son básicamente ya kits que vienen de fábrica. Antiguamente se utilizaba más crear uno su propia metodología. A mí en mi doctorado en sí, cuando comencé, hice mi propia metodología, pero fueron pasando 2, 3 años y ya de repente estaba el boom de los kits de extracción. Entonces uno compra su kit y ahí vienen los diferentes compuestos para, pues, lisar las células, precipitar el ADN, suspender el ADN. Una vez que tenemos el ADN, lo que se utiliza es una amplificación de PCR, que a lo mejor muchos están familiarizados con él por el COVID, ¿no? Donde hacemos nuestro PCR para que ellos identificaran, pues, que estábamos enfermos o no. Y bueno, una vez que se hace la amplificación por PCR, se manda a secuenciar, es decir, plataformas de secuenciación masiva, en donde nosotros buscamos un gen específico, que es el gen 16S, que es un gen que tenemos todos los seres vivos en el planeta, nosotros también, pero cada ser vivo tiene una secuencia específica de ese gen. Entonces, si por ejemplo yo en mi muestra digo, bueno, tengo, no sé, 100 secuencias diferentes de 16S, tengo ya esas secuencias y una vez que las tengo, me mandan los datos, son puras letras, básicamente como un código genético, que yo mediante bioinformática meto a base de datos, que como les mencionaba es una base a nivel mundial donde todas las investigaciones científicas van poniendo los datos de los genes y pues buscar con qué empareja esa secuencia y bueno, llegamos a conocer que está ahí, ¿no?
Muy interesante, doctora. Por cuestiones de tiempo ya nos va a ser posible pasar a las preguntas. Tiene muchas preguntas y le pediría si nos hace el favor de contestarlas, ya sea las que están aquí en Zoom y las que
Sí, las
están en
contesto.
YouTube y las que están en
Ujú,
el canal de YouTube también, le pediría.
ok.
Muchas gracias por su presentación. Y bueno, para no retrasarnos más, le voy a ceder la palabra a la doctora Yadira Almajadaza Hernández Pérez para que continúe la moderación de las siguientes ponencias. Muchas gracias.
Buenas tardes a todos, mucho gusto en saludarlos y un honor estar en este evento tan importante organizado por el Instituto de Geociencias y muy especialmente por la doctora Susana Alaniza Álvarez y todo su equipo. Bueno, pues a mí me toca moderar las ponencias de los jóvenes del bachillerato de la UNAM, específicamente de la Escuela Nacional Preparatoria, y dado que sus ponencias van a ser en inglés, pues me voy a permitir hacer la moderación en inglés. A partir de este momento, ya hemos escuchado a Valeria Gómez, and now we are going to listen to Alexa Ruth Zamorate Ariza and Julio César Juárez Soto. They are students from Escuela Nacional Preparatoria 5, José Vasconcelos, and they are going to deal with the topic Searching for Life, Water and Organics in Space. Please, let us start, Julio César and Alexa.
Yes, teacher.
Okay. Welcome everyone. We are Julian and Alexa, students of Escuela Nacional Preparatoria 5, José Vasconcelos, of Group 603B. Today we're going to talk about something exciting, how water and organic molecules help us search for life beyond Earth. Science believe these are the key ingredients for life. In this presentation we'll look at what we found on Mars, icy moons, and distant planets. We also talk about space missions that are looking for clues. Let's get started. Our purpose. The main goal of this presentation is to explain why water and organic molecules are so important when searching for life. If we know where these things exist, we might have a better chance of finding alien life. We will also see how space missions are helping us learn more about them.
The role of water. Water is the key to life because it helps chemical reactions happen. Every living thing on Earth needs water to survive. Without water, life as we know it wouldn't exist. Water's unique properties. Water is special because it dissolves nutrients, transports them in cells, and keeps temperatures stable. This makes it perfect for life. Without it, cells couldn't function properly.
Where do we find water? Water isn't only found on Earth. Scientists have discovered ice on Mars, and some areas may have liquid water underground. Moons like Europa and Enceladus have oceans beneath their ice surface. Even planets outside our solar system, called exoplanets, might have water in their atmospheres. What are organic molecules? Organic molecules are made of carbon, which is a key of ingredients of life. These molecules include things like amino acids, sugars, and fats. They are the building blocks that make up all living things, including plants, animals, and even humans.
Space are regions of organic molecules. Organic molecules have been found in comets, asteroids, and even interstellar clouds. This suggests that the basic ingredients for life might be common in the universe. Miller-Urey experiment. In the 1950s, scientists created an experiment to mimic early Earth conditions. They found that simple molecules could form amino acids, which are the building blocks for life. This shows that life's ingredients can form naturally under the right conditions.
Evidence of water on Mars. Looks dry and dusty today, but it wasn't always like that. Scientists have found evidence of ancient rivers and lakes. This means that billions of years ago, Mars had liquid water, a thicker atmosphere, and maybe even a climate similar to Earth's. Organic molecules on Mars. The Curiosity rover discovered organic molecules in the soil and rocks on Mars. These molecules don't prove life exist, but they show that the planet had the right ingredients for life in the past.
Methane on Mars. Mars has methane in its atmosphere, and it changes with the seasons. On Earth, methane is often linked to life, but it can also come from rocks. Scientists are still trying to figure out if Mars methane comes from life or geology. Europe's ocean beneath ice. Europe, one of Jupiter's moons, has a thick ice shell, but beneath it, there's a liquid ocean. Heat from Jupiter's gravity keeps the water from freezing completely. This makes Europe one of the best places to search for alien life.
Enceladus water plumes. Saturn moon Enceladus shoots water into space through cracks in its icy crust. These water plumes contain organic molecules, which is exciting because it suggests there might be chemical reaction happening beneath the surface. Titan lakes and chemistry. Titan, another moon of Saturn, is very strange. It has lakes and rivers, but they are made of liquid methane and ethane. Instead of water, scientists wonder if life could exist in a completely different chemical environment.
The habitable zone. The habitable zone is a region around a star where a planet might have liquid water. Planets in the zone are interesting because they could support life. Exoplanets with water. Scientists have found water vapor in the atmospheres of some exoplanets. This is exciting because it suggests that they might have moons, right, or even oceans.
Biosignatures, signs of life. When scientists study exoplanets, they look for specific gas like oxygen and methane that could be produced by living things. Finding this gas together will be a strong clue that life might exist there. Mars rovers, searching for life. NASA Perseverance rover and ESA Rosalind Franklin rover are looking for ancient microbial life on Mars. They are also collecting samples that might one day be brought back to Earth for detailed study.
Europe Clipper investigating ice and water. NASA is sending a mission called Europe Clipper to study Europe's ice and ocean. It will fly close to Europe and analyze the plumes to see if they contain signs of life. James Webb Exoplanet Atmosphere. The James Webb Space Telescope is an incredible tool for studying planets outside our solar system. It can analyze the light passing through a planet's atmosphere and tell us what gases are there. If we find oxygen, methane, or carbon dioxide in the right amounts, it could be a sign that life exists.
Challenge in finding life. Searching for life beyond Earth is complex. We must prevent contamination and distinguish between biological and non-biological signals. To ensure accurate discovery, a spacecraft must be sterilized to avoid bringing air microbes to other planets. Contamination could interface with detecting true extraterrestrial life. Another challenge is identifying real biological signs, as some chemical and geological process can mimic life. Scientists must carefully analyze data to differentiate between natural planetary activity and actual evidence of life. The
Chicos,
future
minutitos, por favor.
The future of space exploration. As technology advances, agents like NASA and SpaceX are planning ambitious missions to Mars, a planet with similarities to Earth and evidence of past liquid water. Crewed missions will allow scientists to analyze samples with sophisticated equipment and adapt research in real time, increasing the chance of finding trace of life. This mission will help answer the question, are we alone in the universe? While also improving our understanding of life's condition and the potential for future colonization.
If we find on another planet or moon, it will be one of the biggest discoveries in human history. It will help us understand how life started if we are alone in the universe. No matter what we find, this journey teaches more about the space science and our own planet. Thank you.
Thank you very much, Alexa and Julio. Please stay here in the Zoom session so that we can have some questions after the next presentation. The next presentation is going to be by Santiago Mendez Ramirez. The topic is organic versus synthetic fertilizers, a question of life and death. Welcome, Santiago. May I remind you that we have only 15 minutes for your presentation.
Yes, teacher. I'm going to start to share my screen.
Yes, please.
And I hope that bájale, Mateo.
Yeah, can you please do the presentation mode?
Yes, sorry. Everything is all right?
Yeah, that's all right. Thank you.
Okay. Good afternoon, esteemed teachers, researchers, and students. My name is Santiago Mendez, and thanks for the opportunity to discuss this topic, a topic that lies at the heart of sustainable agriculture, organic versus synthetic fertilizers, a question of life and death. This is a divide between an organic and synthetic fertilizers, and in this presentation, I'm going to explore both types, their difference, advantage, and disadvantage. So, in this presentation, I'm going to talk about what are fertilizers, organic or inorganic, benefits and dangers, and types of fertilizers. Today, I would like to share you a story that is very close to me, a story of life and work in the fields. So, ever since I was a kid, I have been interested in agriculture. For a life in the countryside until I started to study here in ENP5, the senior high school. So I have been surrounded by fields and animals with my family. My parents told me everything I know about the land and how to work it. Life in the country is not always easy, but there is a profound, beautiful circle in the nature. But a few years ago, we faced a significant challenge. Our lands were almost infertile. Our crops were not growing as we expect, and we know that we had to do something to improve the soil health. And this is where our experience with organic fertilizers began. The goal of this presentation is to understand the potential environment impacts associated with the use of fertilizers. In my case, we decided to use the compost and manure to enrich the soil. It took months, even years, preparing the land before planting any crops. It was a slow and laborious process, but gradually we saw the soil becoming more fertile and crops healthier. I learned a lot with my parents, and I would like to share this knowledge with you. Finally, I hope that at the end of this session, you will gain a clear understanding of how to make informed decisions about these fertilizers. But what is it? An organic fertilizer are composed of animals, plants, or minerals-based compounds to undergo the natural biochemical process like the fermentation. The soil microbes break these materials down into soluble nutrients, making these available for plants. And what is a synthetic fertilizer? Synthetic fertilizers are manufactured through a chemical process like the Haber process, using ammonia, atmospheric nitrogen, and phosphate minerals. They are available in various forms, liquid, powder, and now we know that they are a quick action nature. But what are our fertilizers made of? They are made of nitrogen, phosphorus, and potassium. So, and if you are knowing what is the difference between these organic and synthetic fertilizers, well, the synthetic fertilizers, as you can see in this image, has feed the plant, and the organic fertilizer feed the soil. So the synthetic fertilizer are faster than the organic. In the next table, you can see the organic fertilizers and the synthetic fertilizers. And the organic fertilizers, the nutrient concentration is lower, and in the synthetic fertilizer is higher. The consistency in the organic fertilizer is variable, and in the synthetic fertilizer is defined. The convenience for large farmers, in the organic fertilizer is not convenience for a large farmer, but in the synthetic it is convenience for a large farmer. The nutrient release rates. The release rates of nutrition release is optimal for the plant uptake in the organic fertilizers, but in some case of the synthetic fertilizers, maybe the excessive for a plant's uptake. So this is dangerous. And what is safety for the plants? The plants in the organic fertilizers are more safer than in the synthetic fertilizers. And the effects on the soil in the synthetic fertilizers, we can change this chemical structure with the time. And in the organic, we can make the soil healthy. And finally, the safety for environment. We know the organic fertilizer are safer for the environment, and the synthetic, they had a high risk of leaching of the greenhouse gas emission. Now, some effects of these fertilizers. The organic fertilizers nourish the soil, improving the structure and health over the time. They release nutrients slowly, but ensuring a steady supply of the plants. And the synthetic fertilizer is directly nourish the crops and providing a rapid surge of nutrients. However, the high concentration can lead to risks like root-borne and environment pollution. Now, some advantage and disadvantage of the organic and synthetic fertilizers. First, with the organic fertilizers, the advantage that it improves soil fertility and structure and enhances water retention and microbial activity. Also, it releases nutrients gradually, reducing the risk of over-fertilization, and they are safe for the plants and the environment with a minimal risk of toxicity. But on the other hand, we have the disadvantage of the organic fertilizers. And we may mention this, the nutrient content is inconsistent and difficult to measure. It is slower to show results as composition takes time. The nutrient content varies, making precise application challenging, and they depend on soil microbes, which are not always be active. Now we have the synthetic fertilizers with some advantage and disadvantage. First, the advantage. The precise control of over nutrient concentration and release rates. They measure results often visible with days. The different combining application methods, including foliar feeding and fertigation. On the contrary, the main disadvantage of the synthetic fertilizers are the high risk of leaching and environment pollution. It can alter the soil pH and harm beneficial microorganisms. Also, it requires frequently reapplication due to short-term effects.
Only 2 more minutes, please.
Yes, teacher. Now you can see this image with the fertilizer exposure in the world. The first place is the USA, and Mexico is other country with a high exposure in this fertilization. So if you want to choose one, the organic fertilizers are environment friendly, but have an inconsistent nutrient content and lower results. In contrast, the synthetic fertilizers are cost effectiveness and efficient, so their greenhouse gas emission raise significant concerns. And the organic and synthetic, both types, they have the pros and cons, but you need to apply the right amount in the right moment in the right place. This is a phrase that I like. The best fertilizer for a piece of land is the footprints of its owner, by Lyndon B. Johnson. So what does it mean? It means that these types of fertilizers, we only need to use it when your land is unhealthy. And finally, we have a middle ground. Yes, the answer is yes. We can combine organic and synthetic fertilizers to can winning strategy. For example, you can apply the compost or manure before planting to improve the soil healthy and use the synthetic fertilizer during the critical growth stage for a rapid nutrient delivery. And finally, in conclusion, both organic and synthetic fertilizers have their place in the modern agriculture. Organic fertilizers are ideal for long-term soil health and sustainability, while synthetic fertilizers offer immediate results. By combining the two, farmers can achieve optimal crops yield while minimizing environment's impacts. And the fertilizers are a tool that we must take advantage of it. I have personally used both types of these fertilizers. First, preparing with an organic fertilizer for months or even years before planting any crop. Then, synthetic fertilizer should be applied in the exact moment of peak growth. If we put in the effort, the harvest will be a success. With my family and my father and my mother, I've come to realize that everything is a circle. The food we obtain from the land is used to feed the animals, and later this waste is used to fertilize that some soil, a truly wonderful process. Finally, if we use the fertilizer in harmony with nature, we can maintain the soil fertility, increase food production, and protect the environment. Only to finish, I want to leave you with a reflection. Everything in this life is about balance. That is the key of success. And thanks for your attention. And I hope that this story will provide you a clear understanding of the fertilizers in the agriculture. This is some resources. If you can if you want to watch these articles and the image that I've used. Thanks for your attention.
Okay, thank you very much, Santiago. Now I will ask you to turn your camera on, please.
Okay.
And also to Alexa and Julio Cesar and Valeria Gomez, because we are going to have a very, very, very short session with some questions coming from the YouTube chat. And well, thank you very much, first of all, guys, for these presentations. And now I am going to start for Santiago. What do you think is the future for fertilizers? Santiago, can you stop sharing, please?
Yes, teacher. I think the future of this fertilizer is to combine them and make the soil healthier than with the crops, and maybe obtain the best option for this. As you can see in this presentation, I explained the benefits and dangers of both of these types of fertilizers. But maybe in the future, the synthetic fertilizers will be more safer for the plants and for the environment. But the organic fertilizer is essential key for this for every kind of plant or every kind of fruit and vegetable. So that is my answer.
Okay. Thank you, Santiago. ¿Puedes dejar de compartir tu pantalla, por favor? Pero deja tu cámara prendida. And now we have a question for Alexa and Julio Cesar. You were talking about the possibility of life in another planet other than Earth. And I think there could be a relation with the second presentation that we listened to in this afternoon. So the question by Israel Rodriguez is, what do you think? Is there life on Mars today? And if so, what organic molecules do you think could be found in Mars?
Organic molecules found on Mars mean that Mars had the right chemistry for life in the past, but now organic molecules can also form without life. So we need more evidence to know.
Okay, thank you, Alexa. Well, we have very, very short time, but there is another question, and this will be for you, Valeria Gomez. A question, do you know which tectonic plates were involved in the earthquake, the strong one that we had in 2017?
I'm sorry, I don't know the answer for this question.
Okay, thank you very much, Valeria. Okay, guys, we are going to go ahead. Thank you very much, Julio Cesar, Valeria, Santiago, and Alexa. Thanks a lot for your presentations. And now we are going to go ahead and listen to Maria Fernanda Alba Memetla. She is going to talk about hydroxyapatite. Well, that's a hard to pronounce word for me. From geoscience to regenerative medicine. She is a student from Escuela Nacional Preparatoria number 5. And welcome, Maria Fernanda Alba. You only have 15 minutes. Please take that into account. Fer, we cannot hear you. I think your mic is off.
Yes, sorry.
No problem.
Hello everyone, my name is Maria Fernanda Alba Memetla and I'm excited to present this topic with all of you. I'm a high school student and this year I'm beginning to start one of the most important chapters of my life, my university journey. Ever since I was a kid, I've been dreaming to study medicine, fascinated by how the human body works and how sciences can help to help. Now, I want to take that passion a step further by exploring the connection between earth sciences and human health sciences, especially how materials found in natural like hydroxyapatite play a crucial role in regenerative medicine. This mineral, which exists both in geological formations and in our opponent teeth, is a perfect example of how geosciences and medicine are deeply linked. Understanding these connections can open new doors in medical advancements, helping us develop better treatments and improve human health. With excitement, I'm ready to start, hoping it is of interest of you. And now, when we think about materials that shape both natural world and medical advancements, hydroxyapatite is a prime example. This fascinating mineral is just found in rocks. It's also a fundamental component of our bones and teeth. Its unique structure and biocompatibility have made it a game changer in regenerative medicine, especially in bone grafts, dental applications, and even as a coating for implants. But what makes hydroxyapatite so special? It's chemically similar to the mineral phase of human bones, meaning our bodies recognize and integrate it easily. Scientists have been more exploring ways to synthesize and extract it from natural sources like mammalian bones, fish scales, and even marine shells to create sustainable and bioactive materials for medical use. This natural synthetic connection between geosciences and health sciences highlight just how interconnected in life truly is. Now, but what is hydroxyapatite? Hydroxyapatite is a mineral with the formula calcium 10, polymer 4, 6, and hydroxy 2. Meaning it contains calcium, phosphate, and hydroxide. It is the main organic component of bones and teeth. The HA extracted from mammalian and aquatic sources often contains trace elements like magnesium, sodium, and strontium, which improve biological integration, and its crystallinity is influenced by processing temperatures. High temperatures, about 800 degrees Celsius, yield higher crystallinity HA, while lower temperature results in more amorphous structures. Now I want to talk about the geological origin, because there are two main ways to obtain hydroxyapatite. The first one, the geological, is primarily found in phosphate-rich sedimentary rocks, such as a phosphoritis, which contains high concentrations of calcium phosphate minerals, but in other sources we can find the next ones. The marine sediments. And first of all, we have the terraneous sediments that are from land. First of all, we have the clay, derivative from erosion of continental rocks and transported by rivers and winds into the ocean. And next, we got the sand, found near coastlines, originally from the erosion of rocks and corals. And the silt. There are finer particles than sand, transported by currents and rivers. And finally, the gravel. There are larger rocks, fragments transported by glaciers or strong currents. In the next one, we have the biogenic. They are from biological sources, and we can find the calcium carbonate that comes from the remains of organisms like foraminifera and coccolithophores, the silica produced by organisms like diatoms and radiolars, and the marine fossils like shells, corals, and skeletons of marine organisms accumulated on the ocean floor. We have the hydrogenous sediments that are from chemical processes, and we have the manganese nodules formed by the precipitation of metals on the ocean floor. And we have here an example. The evaporitic deposits of soils like gypsum or halite formed in the enclosed seas with high evaporation, and the phosphorates. There are deposits rich in phosphorus essential for fertilizer productions. There are another example of this sediment. And in the next one, we have the volcanic sediments. They are from volcanic activity. We have the volcanic ash transported by wind and deposited into the ocean after volcanic eruptions. The pumice, floating volcanic rocks that eventually sinks. Also, there is a most common rock in our daily lives. And the pillow lavas, there are an example of this. There are volcanic rocks formed by underwater eruptions. Well, in the next, we have the biological sources. There are mammalian bones, fish bones, and there are where hydroxyapatite forms from the mineralization of biological remains. And the limestone deposits, which can serve as a precursor for synthetic hydroxyapatite productions. Well, now I want to talk about why I consider the promising source of this extraction of mineral. Well, unlike synthetic materials that may trigger immune responses of rejection, hydroxyapatite's biocompatibility and osteochondrotic properties enabling to the bond with natural bond, promoting regeneration and healing. This has driven extensive research into sustainable ways to synthesize and extract hydroxyapatite from natural sources, particularly as we see from natural aquatic environments, where abundant biomineral aid structures exist. Well, one of the most promising sources that we talked about previously of hydroxyapatite extraction is the aquatic life, particularly fish bones, fish scales, and marine shells. These sources are rich in calcium, phosphate, compounds, making them ideal for the hydroxyapatite recovery. Fish bones, for example, are an excellent alternative due to their high mineralogic content and structural similarity to mammalian bones. Various species, including tuna, sea bass, and carp, have been studied for hydroxyapatite extraction. The widespread fishing industry generates large amounts of waste, particularly bones and scales, which will other waste contribute to environment pollution. By utilizing these waste materials, researchers not only obtain a high quality material, but also promote sustainability and circular economy principles. Marine shells, such as those from clams, clams, and oysters, are another valuable source for hydroxyapatite. These shells primarily consist of calcium carbonate, which can be converted into calcium phosphate through specific chemical treatments. And the use of marine shells is particularly prevalent in regions with significant shellfish industries, like such as coastal areas in Southeast Asia, India, and the Mediterranean. Well, these locations provide an abundant and cost-effective supply of raw materials for hydroxyapatite productions, further reducing waste in seafood industry. The extraction processes varies depending on the sources, but common methods include calcination, alkaline hydrolysis, and chemical precipitation. The calcination involves healing fish bones
Only
or
2
marine
more
shells.
minutes. But it's only 2 more minutes, please.
Yes. One of the key advantages of extracting hydroxyapatite from aquatic sources is the presence of trace elements such as magnesium, sodium, strontium, and zinc, which enhance the biological properties of the final material. These elements are naturally present in fish bones and marine shells and contribute to improved bone regeneration, increasing osteoblast activity, and better chemical properties of hydroxyapatite implants. These make aquatic derivative hydroxyapatite a preferred choice for medical applications, particularly in bone and dental tissue engineering. Well, now I want to talk about a little bit of laboratory synthesis, because scientists can also create hydroxyapatite in a lab using chemical process. The main methods include the precipitation, mixing calcium and phosphate solutions to create HA, hydroxythermal method using high pressure and temperature to form HA crystals, and the salt gel method, a technique that creates very fine HA particles. Well, the natural hydroxyapatite is often preferred because it is already contains small amounts of other elements like magnesium and strontium, which help with the bone healing. Now, the medical applications. Well, hydroxyapatite has many uses in medicine because it is so biocompatible, meaning it works well inside in the human body. Some of the most important applications are the next ones. The bone regeneration. The doctors use hydroxyapatite to repair broken bones and fill it bone defects caused by injury or disease. It serves as a scaffold, allowing new bone cells to grow and replace the damaged area. The next one is the most common to see, the dental implants and cloring. In dentistry, hydroxyapatite is used to coat dental implants. This helps the implant, the bone with the J-bone, making it more stable and non-lasting. And the next one is so interesting because hydroxyapatite can also be used to deliver medicines directly to the bones. Tiny HA nanoparticles can carry antibiotics, anti-inflammatory drugs, or even a cancer treatment to specific parts of body. And this is related with the previously, because for people who have received radiation therapy for cancer, their bones may become weak and struggle to heal after surgery. Scientists have found that using hydroxyapatite coating implants can help these patients by promoting better bone attachment and healing. And finally, I want to talk about the future perspectives. Well, the future hydroxyapatite research is exciting and full of possibilities. There are the 3D printed bone scaffolds, custom designed implants made specifically for eventual patients, the smart biomaterials, and hydroxyapatite combined with antibacterial and growing promoting materials to enhance healing, and the eco-friendly production. Scientists are working on sustainable ways to produce hydroxyapatite from waste materials like eggshells and fish bones. Well, in conclusion, we have to say that working on these presentations has been an eye-opening experience. showing how something as simple as fish bones or cheese eggs can be turned into a life-changing material for medicine. Hydroxyapatite, the mineral found both in natural and inert bones, has proven an incredible tool for bone regeneration, dental repairs, and even implant clothings. Well, this presentation has also made me realize how connected different sciences fields are. Geosciences, chemistry, and medicine all come together to create something that can improve people's life. It's been pretty exciting to explore how material from the Earth's crust can transform it into something that helps the human body heal. And plus, knowing today's approach reduces waste and promotes sustainability makes it ever more rewarding. Without further ado, I thank everyone present for their attention. See you later, and thank you again.
Thanks very much to you, Fer. It has been a very interesting presentation. And please wait here because we are going to have a set of questions after the next presentations.
Yes.
So right now we are going to listen to Sebastián Ruiz Román and Leonardo Daniel Lozano Tobar. They are students from Escuela Nacional Preparatoria número 5, José Vasconcelos, and they are dealing with a topic related to what they want to study in the future. So the title is Black Holes, Their Origin, Formation, and Significance in the Universe. Welcome, guys. You have 15 minutes to present this very important topic.
Thank you. Good afternoon, everyone. Today we are very excited of presenting this topic, especially to such a distinguished audience. I think that we all like to stare at the sky, especially at night is something that I really enjoy to do, and sometimes I wonder what are the mysteries that are hidden outside on the universe. Well, imagine that I tell you there is a region on space that rewrites the rules of reality. The light bends, the time grabs, and the gravity is so intense that not even light can escape from there. This is what we know as a black hole, and today we're here to take you on a journey. So let's dive into what they are, how they are created, how we know they are real, and why their story is very important. So let's start.
So, well, what are black holes? Well, black holes are one of the most fascinating and enigmatic objects in the entire universe. Their existence challenge our understandings of physics from general relativity to quantum mechanics. So we will explore their origins, theoretical development, observational evidence, and significance in modern astrophysics. A black hole isn't a hole you'd fall into like a trapdoor. It's a region in space where the gravity is so powerful that nothing, even light, can escape from its pull. At its heart lies the singularity as we see in the picture, a point of infinite density where the laws of physics, as we know, they break down, as Hawking said in 1975. Surrounding it, as we clearly see, is the event horizon, the invisible boundary marking the point of no return. Cross it and you'll be swallowed into a mystery that we are still trying to decode. In 1783, Cambridge professor John Michael proposed that a sufficiently massive and compact star could have such intense gravity that even light couldn't escape. However, these early ideas were inconsistent with Newtonian physics, as they require a proper understanding of the gravity affecting the light, which was only fully developed with Albert Einstein's general relativity theory in 1915. And Einstein showed that the massive objects warp space-time. And in 1916, Carl Schwarzschild found a solution to Einstein equations. This describes a gravitational collapse so extreme it forms what we know a black hole. And John Wheeler coined the term that it's black hole, giving this to the cosmic enigma.
Well, now that we know what is a black hole, let's talk about how they are formed. First of all, we have to start from the idea of what is a star. A star is a perfect balance between an expansion force and a compression force. The expansion force is caused by nuclear fusion reactions that are happening on the inside of the star. But also its massiveness create a deformation on the space that surrounds the star. To this deformation is what we know as gravity. So while gravity is compressing the star, the nuclear fusion reactions are trying to expand. But when the nuclear fuel starts getting exhausted, the gravity starts winning. When the nuclear fuel is completely exhausted, the star has different possible fates. One of them is to end as a white dwarf if the star is less than 1.4 solar masses. It can end also as a neutron star if the star is about 1.4 until 3 solar masses. But if the star is even more massive than this, about more than 3 solar masses, there's no known force on the universe that can prevent their collapse. So they will end as a black hole.
Then let's talk about the types of black holes. Well, there are three types of black holes. The stellar black holes that form when massive stars exceed the sun mass exhaust the nuclear fuel. Without fusion to push outward, the gravity wins, collapsing the star core into a singularity in a supernova explosion. Then we have the supermassive black holes. These are millions or billions of times the sun mass, likely grow from smaller black holes merging or gobbling up matter over eons, perhaps seeded by the universe's earliest stars. And finally, we come with the primordial black hole. They are a hypothetical vestige from the Big Bang's violent birth, form as space itself crumpled under extreme density. This was discovered by Carr and Hawking in 1974. Well, you can see a black hole because it's invisible by definition. So how do we know they are there? In 1960s and 1970s, studies by Roger Penrose and Hawking lead to the cosmic censorship hypothesis. This suggests that singularities are always hiding within even horizons. This prevents direct observation, but their presence is inferred through their effects on surrounding matter and light. Then, gravitational waves are detected by LIGO and Virgo from black hole mergers in further their supports in existence. In 2015, LIGO detected gravitational waves from two merging black holes. This confirmed the Einstein predictions and earned the 2017 Nobel Prize in Physics. Well, one of the most compelling pieces of evidence is the Sagittarius A, a supermassive black hole at the center of the Milky Way, whose existence was confirmed by the orbits of the nearby stars. The first ever image of a black hole, as we see in the screen, was taken by the Event Horizon Telescope in 2019. This provided direct visual information and confirmation of the shadow of a black hole. Then I'm going to talk about the Chandrasekhar limit. Well, the Chandrasekhar limit is a limit that is delimited by 1.4 times of the sun. So this limit is a fundamental concept in astrophysics that this determines the final fate of a star based on its mass. So as we clearly see in the presentation, if you have a black hole, then you have the nuclear fuel exposed in there. It contracts into some gravitational forces, and well, if you have the remaining mass is below 1.4 of the limit, the electron degeneracy resists for being squeezed, and it results in a white dwarf. Then we have the neutron star, that the neutron star is the one that is created by the Tolman-Oppenheimer-Boltzmann limit, that is 2 to 3. And finally, for creating a black hole, the mass exceeded is the 2 to 3, and the gravity can get all that. The neutron degeneracy pressure made the star collapse into the black hole?
Well, now let's compare these objects because they are very, they are, we can think that they are the same, but no, there's a lot of differences. First of all, the black hole. As we know, the black hole results from the collapse of a massive stars that has more than the three times the solar mass. Its size is infinitely small, and the inside of the singularity, and its density is infinite too. They are structured by the event horizon and the singularity, where the singularity is the point where nothing can escape from there, and the event horizon is the point of no return. Is like a ring that surrounds the singularity. The gravity, as we know, is so strong that that not even light can escape from there, and we can detect them by the gravitational effects like gravitational waves, and their composition is unknown. This is unknown because relativity breaks down on the inside, and we cannot see what is inside of them, so we really don't know what are they composed from. Now let's talk about the neutron stars. As we know, the collapse of neutron stars of about 1.4 until 3 solar masses creates a neutron star. Their composition is mainly by neutrons and some other exotic particles. Their density is very big because this star that has more than the mass of the sun ends as the size of like Mexico City, about 15 to 25 kilometers of diameter. So their density is very big. A spoon of one of these stars can weigh about 100,000 million of tons. They're structured by a core of neutrons and a crust of iron. Their
Two more
gravity is
minutes, please. 2 more
yes,
minutes.
teacher. Their gravity is extreme, but it allows radiation emission, and we can detect them by pulsars. Now let's talk about quark stars. That these are hypothetical. They are like the middle stage between a black hole and a neutron star. They are smaller than a neutron star, and they are even denser than a neutron star. They are made by a state of matter named as core of quark gluon plasma. We haven't discovered it yet, but theoretically this exists. Only that we haven't seen one of these.
So some interesting facts of black holes are the largest black hole is Stone 1618 that has a mass over 40 billion times the sun mass. Then we have that the time is low down near the event horizon. This is through a time dilation that was discovered by Joan in 2020. Another interesting fact is some black holes eject powerful jets of plasma that travel close to the speed of light.
Well, but why does this matter? Why is very important to study these objects? Well, it is important because black holes challenges everything. They are regions of the space where physics breaks, so they force us to rethink our laws of physics. So their study can help us to understand in a better way what are the laws of physics that governs on our universe. They serve us as cosmic laboratories to test all our physics theories, but also supermassive black holes like the one on our Milky Way center, that's name is Sagittarius A, play a critical role on the galaxy evolution. This is because they regulate the star formation by expelling energetic outflows, and they also shape the interstellar medium. They also scientists link them, recent studies made by scientists link them to the dark energy that we think that this is the thing that drives the accelerated expansion of the universe. So their story can help us a lot to understand what is the place that humanity has in our universe.
And finally, these are our conclusions. Well, black holes, as we clearly say, are regions where gravity is so intense that nothing even light can escape. And so through these presentation, we learned that black holes are not mere theoretical curiosities, but they are real entities that shape our universe and force to question back basic concepts like space, time, and transformation. This knowledge affects us by broadening our perspective on cosmos, fostering a sense of wonder and curiosity, and potentially driving technological advancement in our area. So as proposal, we could invest in technologies like more powerful telescope to observe these interesting phenomena, and in greater in detail, so we could develop advanced computer simulations to explore their formation and dynamics, so we could inspire such areas as quantum mechanics and explore more about the universe.
So to conclude, I want to make emphasis on the enormous importance of this because in the future, these studies can lead us to generate more advanced technology to solve a lot of questions that we all made us, like why are we here? Where do we come from? What is the place of us on this universe? What we can do, what we cannot do, and we can understand in a way better, on a better way, all the things that surround us, not talking on the earth, but on all the universe. So this is why this is a very, very important topic that scientists are trying to study more to solve all these questions that have been made by decades. Thank you for your attention.
And that's all. Thank you for all.
Thank you very much, Leonardo, Daniel, and Sebastian. And please stay here so that we can answer, well, you can answer some questions in some more minutes. But right now we are going to listen to Natalia Reséndiz González. She is also a student of Escuela Nacional Preparatoria 5, José Vasconcelos, and she is going to be talking about ocean acidification and its effects on coral reefs. Welcome, Natalia. You have 15 minutes. Please go ahead.
Can you see my presentation?
Yes, we can. But I think that we are in the last slide.
Yes. Okay. Good afternoon, everyone. My name is Natalia Resendiz, and today I'm going to talk about a critical issue that is affecting and changing the chemistry of the oceans all around the world. I hope you enjoy it. It is the ocean acidification and its effects on coral reefs. Before I start with my presentation, I would like to tell you the reason why I decided to talk about this. I chose this topic because ocean acidification is a silent crisis which a lot of people still don't know about, which is a little really concerning. Also because corals are vital for marine life, coastal protection, and millions of people's livelihoods. However, coral reefs are disappearing because they are dying, mainly due to the rising levels of carbon dioxide, which is mainly produced by humans. So I think that raising awareness is the first step toward protecting and before it's too late and we suffer from concerning consequences that may affect humanity. And I think each one of us can do something to help our world. Well, the objectives of this presentation are the following. The first one is to explain the phenomenon. We will see what ocean acidification is and how it harms coral reefs. Then we will analyze the consequences. We will see that this phenomenon doesn't just affect coral marine life, but also humans. And last but not least, we will explore solutions. We will see what we can do to prevent further damage in the future. Everyone knows that coral reefs are incredibly important for marine ecosystems. But why are they so important? Well, they support about 25% of all marine life, providing food for a lot of organisms. This includes 4,000 species of fish and countless other species like invertebrates and marine plants. Corals also act as natural barriers, which protect coastal communities like the one you can see over here. Corals protect them from storms and erosion by absorbing the wave energy. Now imagine that this beautiful view turned into this, a lifeless underwater desert. This image over here shocked me a lot because this coral reef used to be alive. Fish used to swim there. Corals used to have color. Everything and that kind of stuff was different. But now what we can see over here is completely dead now. And this is caused by phenomenon called ocean acidification. And we will see what is that. Well, ocean acidification is also referred as eutrophoresis of the sea. It occurs when the ocean absorbs the excess of carbon dioxide from the atmosphere, leading to a decrease in pH levels and making the seawater more acidic. At the beginning of, no, at the average pH of the ocean was approximately 8.2 before the Industrial Revolution. But today, the pH of the ocean is 8.1. It has decreased because of the ocean acidification. And it is spread that when the 21st century end, the pH will drop to 7.8, bringing a lot of consequences to marine life, especially to organisms that have calcium carbonate in their skeletons, like coral reefs do. Now, what happens with ocean acidification is that, well, the gas is in the atmosphere, produced by the burning fuels, the cars, the fabrics, and all that stuff. And the ocean absorbs it, and then it is dissolved with water, which forms carbonic acid. And this one later breaks down into hydrogen ions and in bicarbonate ions. More hydrogen ions make the pH decrease, and it also reduces the availability of another ion called carbonate ion, which is very important for coral reefs. Now we will see how does ocean acidification affect coral reefs and marine life. Well, coral skeletons, the first problem they face is in their skeletons and in their growth, because coral rely on carbonate ions to build their skeletons. With no carbonate ions available, their growth slows down, making them weaker and also vulnerable to damage from, for example, storms, human activity, and also predators. So this means that corals lead to collapse when they can't build their skeletons as usual. And this problem is related with this one, coral bleaching. Coral bleaching occurs when the rising temperatures of the ocean and the increased acidity stress corals and causing them to expel an algae called zooxanthellae algae that lives inside them. This algae is very important for them because it provides 90% of their energy, and also gives them the beautiful color of the coral reefs. Here we can see that Here's the succintillae algae inside the coral. The coral right now has color. It is strong, but when the temperature rises and the acidity also does, the succintillae algae is expelled. It takes out, and the coral turns white and weaken. And with the time, it may eventually die. Like I put the image right here. We can see that this coral is completely dead before the coral bleaching. Also, there's an impact in the marine life. Only for coral reefs support over 1 million species and about 25% of all organisms. And if reefs disappear, a lot of species like fish, sea turtles, invertebrates, and other organisms would struggle to survive, making chain reactions throughout the marine food web. Now, I will explain you the general consequences. The first one is the loss of marine biodiversity. The coral reefs cover only 0.1% of the ocean floor, but it provides habitats for more than a quarter of all marine species. So losing coral reefs would mean the extinction of countless marine organisms, disrupting the ecosystems worldwide. Another consequence is present in the economic impact. The coral reefs contribute globally to the global economy with $375 billion annually through fisheries, coastal communities, also tourism, and declining reefs will mean that fisheries would collapse, especially, and it would affect a lot the coastal communities. It would affect the food supply for these people. Also, it would be some places and some countries like the Great Reef in Australia and the Caribbean would be really affected because they are these places are tourism dependent and they would suffer from financial losses. And before I have said that, I would like now to explain what we can do to prevent another kind of consequences, mainly for the posterity and for the people.
Only
Yes,
2 more
teacher.
minutes, please.
Yeah. What can we do to help with this problematic? Okay. The first thing we can do is to reduce the CO levels by, for example, switch to renewable energy, like using the solar and wind power, for example, or use the public transport like bike or walk. If you are near the school, for example, instead of using your car, you can go walking, and that would be really useful to help with this problematic. You can also, when you're at the beach, when you're on vacation, you can protect the coral reefs by avoiding touching them or collecting the corals, and also reduce the plastic waste to prevent pollution, because this pollution reaches the corals and also these ecosystems are really affected. So to end up, I would like to tell you that small actions add up. By working together, we can ensure that coral reefs continue thrive for generations to come, because posterity needs our help. Our sons needs our help. Now, in conclusion, I have that ocean acidification is a serious and urgent threat caused by carbon dioxide emissions, which weakens coral skeletons, triggers coral bleaching, and disrupt entire marine ecosystems. Coral reefs play a crucial role in marine biodiversity, economic stability, and coastal protection, making it essential to take action now. So that's all for my part. I hope you enjoy it, and thank you.
Thank you very much, Natalia. This was a very interesting topic. There is a comment at YouTube saying, good topic. We went over that in my biology class, and yes, it is worrisome. And yeah, you also caused an impact in many of us with that terrible contrast that you showed between the living coral reefs and the dead coral reefs. So may I ask Sebastian, Leonardo, Daniel, and Fer Alba, please turn your cameras on, guys. And we are going to have very few questions about your topics. The first one is for Fernanda Alba, and the question is, how did you know about this topic? It is so interesting. How did you get to know about it, and how did you become or started studying it?
Well, for my topic, I wanna relating the geosciences with the medicine. So I research, and hydroxyapatite is a perfect bridge with. I consider the geosciences with the medicine, the extraction of this mineral, and the implement of regeneration of bones, and the clinical implants of dentistry are some examples of how hydroxyapatite can help to the medicine.
Thank you very much, Fer. We really are running out of time, but there's another question for Leonardo, Daniel, and Sebastian. The question is, can you explain how black holes die in case they do?
Yes. Well, to explain these questions, we have to enter into a very difficult theme that is a very difficult topic that is quantum mechanics, but this is explained by Hawking's radiation. As we know, because of quantum mechanics, there exist particles and antiparticles. So in case that that this pair of particles were created near the event horizon, that as we know is the point of no return, if one of these particles enters to the singularity and the other one goes away from this, and the particle that enters is antimatter, this will create like to the matter inside of the black hole to evaporate. This won't happen because black holes are very, very massive. To this to happen in a human lifetime, the black hole has to be like about a mountain, the mass of a mountain squeezed into a smaller than an atom for them to disappear in this way. But yes, they could die, but it's very difficult that this happens.
Thanks a lot, Sebastian and Daniel. And now, Natalia, teacher Sergio Reyes asks, what was the hardest part of your research?
I think the hardest part was to look up for all the consequences that phenomena has, because they may not be a lot, but they are very specific, and I really wanted to show you the really problems, the most worst problems that the phenomena has. So I think it was the consequences, because a lot of organisms are affected, but I didn't know if I should include like more, like all the animals, or another interesting facts, or like another kind of values, like for example the pH. I think that it has been like really interesting for me to take a look about this topic, and if I had to choose what was more hard for me to explain or to look for the information, I would say the consequences.
Thank you very much, Natalia. Yes, it's hard to decide on whether to include something or not. Thank you very much, Natalia, Fer, Alba, Daniel, and Sebastian. And now we are going to continue and listen to Daniel Soriano Arteaga. She is going to talk about the day the sky fell, the end of the dinosaurs. Daniel, we are a little bit late, but don't worry, you still have your 15 minutes. So work at ease, no problem for you. I will tell you when it is only 2 more minutes to end. Is that okay? Okay, Daniel, go ahead.
My transmission is so right. Look yeah, his look, right?
No, we are okay. That's it.
Yes.
And now, can you start with the presentation mode, please?
Okay. Yeah. Hello, everyone. My name is Daniel, and I'm talking about the extinction of dinosaurs. First, oh, sorry. I'm sorry. Okay. It's look right, or
we are looking at a slide that says the asteroid theory.
Oh, okay. Wait 1 minute, please.
We can see that your connection is kind of slow.
Yes. Oh. Okay. First of all, I will give a brief explanation about the period in which this situation occurred, which marked a turning point in the story of life on Earth. It was in the Cretaceous period, which comes after the beginning of the dinosaurs, which took place in the Jurassic period. The Cretaceous period began approximately 144 million years ago and then 66 million years ago. The Cretaceous was the third of the last period in the Mesozoic era, a time when the dinosaurs dominate the Earth with astonishing diversity and magnitude. During this time, there was a supercontinent called Pangea, whose name is all the land, and a gigantic landmass that united all the current continents into one. However, at to the beginning of this period, Pangea began to fracture and separate, giving rise to the continents we know today. This process of continental separation had profound consequences. It's caused significant climate change and that drastically affects the planet's flora and fauna. Theoretically, it is said to this fragmentation and the resulting environmental change, dinosaurs were already beginning to experience difficulty surviving. Even before the asteroid impact, one of the causes of this incident extinction was the massive eruptions of volcanoes, since dinosaurs were mesotherms, meaning they depend on a warm, unstable climate to regulate their body and maintain inactivity metabolism. I thought to three theories of this. The attempt to explain the climate change and catastrophes that led the extinction of the dinosaurs. Mainly, I will talk about the asteroid impact theory, which is the best known, but crucial to emphasize that before this catastrophic event, Aris mentioned earlier massive eruptions were already occurring, which played an important role. The theory of the volcanoes focused on the Deccan Traps, a volcanic formation located on the Deccan plateau in India. This region was home to one of the largest concentrations of volcanoes on the planet, and these activities is believed to have played a primary role in the extinction of the dinosaurs. This volcanic activity intensified approximately 68 million years ago, about 2 million years before the meteorite impact. The massive eruptions released enormous amounts of greenhouse gases, such as carbon dioxide, which caused a gradual increase in enormous amounts of global temperature. As I have already mentioned, dinosaurs were mesotherms, and this extreme climate change left them without the ability to regulate the body temperature. Next, we will talk about the theory. First asteroid, this name is Chicxulub crater. That's named in the crater form of the Yucatan Peninsula in Mexico. This crater, with a diameter of approximately 118 kilometers, is an imposing scar of the collision that changed to the course of life on Earth. The impact released an unimaginable amount of energy, creating radioactivity from the iridium present in the asteroid that even triggered asteroid catastrophes such as a rain, tsunamis, and devastating the destruction. Mainly, there is talk about to the release of soot and dust since the rocks of the Yucatan region are rich in hydrocarbons. The soot and dust rose into the atmosphere, blocking sunlight and plunging the planet in prolonged to darkness. The fact of sunlight severely affects the flowers and the preventing to the photosynthesis and causing the death of plants. This in turn left herbivores and dinosaurs. The food is dead, but the herbivorous dinosaurs with the food of plants and this extinction. And the carnivorous dinosaurs eat herbivorous dinosaurs, but this extinction. Leading to their extinction reservation. However, recent research has revealed that the asteroid also contained large amounts of sulfur. The sulfur released into the atmosphere, form aerosols, and contain large sunlight that cause drastic global cooling. This cooling up to the darkness creates an inhospitable environment for dinosaurs, who were not adapted to extremely low temperatures. This one estimates that only a small percentage of dinosaurs possessed some resistance to cold, but it was almost impossible for them to survive in the extreme conditions that were to generate there before the warm and stable environment of Pangea was transformed that into a frozen and dark hell, which triggered on the mass extinction of the dinosaurs. In this theory, is the discovery of sulfur in the Chicxulub crater led to the discarding the theory that soot was solely responsible for the extinction. However, the discovery of soot in Spain, coming from the Yucatan, and confirmed the both of soot and sulfur its effect in this extinction. The second theory, we will explore to the theory of the second asteroid. For a long time, scientists wondered if the Chicxulub impact is the only catastrophic event to the extinction of the dinosaurs. It's only in 66 million years ago. Recently, a crater called Nader was discovered in the western of Africa, buried into layers of sand. This crater named for this after a nearby submarine volcanoes could be the result and another asteroid impact. Although it was smaller than the Chicxulub asteroid, a recent study has confirmed that another crater is to form 66 million years ago, coinciding when the Chicxulub impact. It is believed that another impact had regional effects. A difference of the Chicxulub, where is the effects it's around the world. The another crater, the another asteroid, it's only in the regional of Africa, west of Africa. It's believed that another impact had regional, such as tsunami and earthquakes, but did not trigger a global extinction. However, some research suggests that the Chicxulub asteroid might have fragmented before impacting Earth, and that another world we want of the fragments. This theory raised the possibility that the extinction of the dinosaurs was caused by a rain asteroid, but it's only extinction of Africa. In conclusion, the Cretaceous Paleogene mass extinction represents a critical turning point in the story of life, an event that not only marked the end of an era dominated by the dinosaurs, but also reshapes the planet's evolutionary trajectory. Although the impact of the Chicxulub asteroid is an indisputable protagonist of the catastrophe. The complexity of the scenario requires a deeper look in the interaction of multiple factors. The impact theory supports the irrefutable evidence of the Chicxulub crater and the global iridium anomaly, offers a compelling explanation for the speed and magnitude of the extinction. However, Earth was not blank canvas of the time of impact. The intense volcanic activity in extinction in the decatraps, which precede and extend beyond of the Chicxulub event, have already introduced to significant disturbance in climate and ocean chemistry. These massive eruptions, with their release of greenhouse gases and aerosols, may have destabilized ecosystems, making them more vulnerable to the asteroid impact. The recent identification of of the coast of Africa adds another layer for complexity to the picture. The possibility of multiple impacts or fragmentation events in the main asteroid suggests to the Earth may have been bombarded by multiple projectiles and short period of time. This hypothesis raises intriguing questions about the timing of the impacts and their relative contribution to the extinction. Beyond the immediate catastrophic events, the long-term effects of the extinctions were equally profound. The blockage of sunlight to global cooling and oceans acidifications cause a cascade of extinctions at tropic levels. The disappearance of large terrestrial herbivores and carnivores opened ecological niches that were quickly occupied by mammals, which until the half remains the background. The Cretaceous Paleogene extinctions teaches us that in life on Earth is vulnerable to catastrophic events, but of extraterrestrial and terrestrial origins. It also reminds in that terrestrial systems are complex and interconnected, and that disturbance in an area can have dominion that paved the way for the rise of mammals. And eventually,
Daniel, we really need to finish now.
What?
1 more minute, please.
Okay,
we need to finish.
And eventually, for the emergence of humanity. It is a reminder of the unpredictable and often violent nature of Earth's history and of the importance of understanding the process that have shaped on the planet and life inhabits it. It's finished. Yeah, thank you.
Thank you very much, Daniel.
Yeah.
And now we are going to skip one of the presentations because the presenter is not going to be here. And we are going to go straight to the oceanic crisis, how oxygen depletion is redefining life on Earth. And the presenter is Zaira Richel Zambrano Uribe from Escuela Nacional Preparatoria número 5, José Vasconcelos. Welcome, Zaira. You are very welcome here. Let us start, please.
Thanks, teacher. Yes, I'm Zaira Zambrano, and I'm a student at Prepa 5 UNAM. I'm in 6th grade, and talking more about me, I wish to become an earth scientific because since I was younger, I was very interested in learning more about the planet, more about all those topics because I love the planet and this is our only home. And why is this so? Is this topic so important? Because this topic is not have the attention that it deserves, because this topic has the importance for redefining life on Earth in ways that we are not fully to understand. This topic is the oceanic crisis, how oxygen depletion is redefining life on Earth, or in other words, the oceanic anoxia. So why is this so scary? Because this is not an issue from the Earth's past. This is happening right now, and if we want to survive, we have to do it something. Having a look from the past, this is very decisive from other extinctions because, as we know, in the earth there are so many systems like the biological system, the physical systems, and they are interconnected, and this is so harmful because they are so vulnerable, and as the tiny change it can change a lot. So for study this topic, I will explain you about the Permian Triassic extinction, the Toarcian Triassic extinction, and the Cretacic extinction, or called the 082. The next, please. What are the causes of the disruption of the levels of the oxygen? As we know, you can probably say to me that is the activity by humans or is just the climate change? And yes, you are correct. There are the climate change, but there are other mechanisms. For example, in the water, there are so important cycles. The natural cycle of the ocean that happens when the natural water, that is the warm water on the tropics or in the surface, is very density. So this water need to go down from the deepest water because this is the cycle, and the oxygen needs to be down for all the animals, all the organisms that need to breathe and need to use those oxygen for their metabolisms. So this is other mechanism that can have a disruption on the nutrient runoff. If the cycle don't act well, the nutrient runoff will have probably disruptions like, for example, the natural cycle of the nitrogen that is only used for something like algae bloom is very harmful, and the natural processes. The next, please. The Permian Triassic extinction. This happened at 252 million years ago. And this is important because, as many researchers have said, this extinction have dissolved all the
materials, all the animals. The animals in this period have died. Mostly the 90% of the animals and organisms like bivalves, ammonites have died. And in the image, as you can see, the Pangea, there is the point purple, there are the fossils. The fossils are more in the tropics because there are the warm water, and in the tropics, as we know, the warm water can hold less oxygen, so they are more sensible for these extinctions. And as we can see in the South Pole and in the North Pole, there are less number of extinctions for this period. The next, please. The Toarcian oceanic anoxic event. This happened at 183 million years ago. A researcher that I searched in some other weeks and said that this happened for all the volcanic eruptions, all the massive volcanic eruptions that occurs on the part on those regions. For example, I know that in the formation on the Earth, there are so many changes on the tectonic plates that are forming all the new surface. For example, in this image, we can see the enhanced hydrological cycling that provides the nutrients that forms the algae and cyanoblomes. And we also add the turbidites that provides denitrification, denitrification that forms the algae and cyanoblomes. During this process, the massive clumps of lava, carbon dioxide, methane have disrupted into the atmosphere. And if we add the denitrification, there are so very toxic for also the terrestrial and the marine life. So it's important to consider that the nitrogen and all this process about the greenhouse gases have a greenhouse effect, and if we add to those gases, we also have an important case of acidification of the oceans. This is very harmful for this period because during this period there are other organisms that need the oxygen, and if there is not, they can live, they can die. So the ammonites, for example, as I mentioned in the other extinction, the ammonites need the calcium and the carbonate calcium to add into their structures of their bodies. So the acidification doesn't leave those organisms to survive. The next, please. The Cretaceous Oceanic Anoxic Event 2. This happens at 94 million years ago. As you can see, the pattern is the same. The volcanic eruptions that deplete ocean oxygens because they plumb a lot amounts of kilometers of lava. And there is a little bit different from the other two because on this, we have a bloom of the material, biological material. The biological material also have to die, and this material is going to the deepest part of the ocean in the process of decomposition, they produce a lot of toxic gases like nitrogen. And if we also are having a problem of anoxia and the problematics of all the gases that we have in the atmosphere, and if we also add all the decomposition, we are exacerbating all the anoxic problem. For example, in the image, there is the cold cliff, the Caribbean large igneous part that is a very important part in the earth that is very active in the volcano eruptions. So this is considered the last biggest extinction that disrupt in the earth.
The next, please. Other thing is that it's not just from the past. As we can see, it is happening right now. For example, I get very, very confused, very worried because I discovered that there are so many dead zones. The dead zones are called the parts that there are any oxygen, there are any life. And the image, there is the Gulf's, the Mexico's dead zone. And there is not just only one dead zone. There are a lot of dead zones in the important industrial parts, in the economic parts of the earth that human activity do overfishing, do other things like industries, petrol industries. And this is important because the concentrated dead zones are just in the important countries. For example, I searched that there are an important dead zone in the part of Europe that is considered one of the most activity processes about the industrialization and other things like this. And this is so worrying because other articles show that if we continue like that, the temperature, global temperature of the earth will increase more than 8 to 10 degrees. And this is so worrying because if the climate change is causing all of those problematics, if we add also the processes of adding pollution, overfishing, and those things are very worrying. And other studies have shown that in the earth, if we continue like that at 2100, the percentage of the dead zones, the algae mentality of overfishing are going to exacerbate, and the anoxia are going to increase to 30%. The next, please. As we know, environmental consequences are not fish kills because other organisms are going to die. The habitat degradation, it's very important because there are some habitats that are very sensitive to the changes on oxygen. For example, the mangroves, the seagrasses are a very specific parts in the planet that provides us some oxygen, some helpful benefits, but they are very in danger because we are also deforestation and we are building a lot of houses, industries, and we have to protect them. Altered food webs, because if the most important organisms like phytoplankton and algae died, the trophic web are going to have a decay. Like if an algae die, a fish die, a shark die, and even other organisms are going to die. This is very harmful for the people because other people have the resources because they use the fishing. They use the fishing for live, and when they fish and they got the resources to live, like money, and we lose economic services, other services that we are not just related to fishing, but there is very important to consider. The next, please. What we can do? Thinking ahead, creative and innovative solutions. I have searching that we can have a lot of benefits in our house to reduce this impact. As you are going to think, oh, how do I can do for the planet if I am in my house? You can do a lot. Just starting to reduce your pollution or to reducing your daily waste, like doing some exercise
in other things that you can have. For example, other innovative solutions are to use technology to create a drone that can swim into the water to control the oxygen levels. Other thing is to have a very innovative solution in the coast that is not fishing, because fishes are very important to the traffic stream. And for example, if we start doing things like having more voice into social media, we are going to have more audience that can take more control, make conscious about their decisions. And when I was younger, I made an Instagram account. This Instagram account, I used it for sharing posts about these topics like anoxia, about the global warming. I can see that a lot of people can have their own problematic in their house, and they can move it from other places that are in the same phenomena.
Zaira, only one more minute.
Yes, so I bet you that you can use an Instagram account or something, just like giving an advice to your friends or family to promote those habits, like using cycles, or just to walk to their works. Yes, and this is what we can do. And this is an advice because we are in the best moment of that we can act. If we don't act, we are going to be in the other situations of the other extinctions that have happened in the Earth's past. As we can see, there are not just our causes. This is about everything, the mechanisms of the earth, and everything is connected. I hope that you can enjoy my presentation. So think ahead and please make other things that we can help our planet.
Thank you very much, Zaira, Rachel. That was very interesting. And we can feel your concern about this topic, which should concern all of us. And now we are going to welcome Ricardo Castillo and Mauricio Osnaya Juarez. Both of them are students from Escuela Nacional Preparatoria 5, and they are going to talk about another concerning topic, which is traffic jams and their effects upon the planet. Welcome, guys. You may start. You only have 15 minutes, please.
Okay. Wait a minute. Okay. Okay.
Hello, everyone. Good afternoon. We are Mau and Richie from the Prepa 5 UNAM, and we are going to talk to you about traffic jams and their effects upon Earth. We hope you can find this topic as interesting as we do. With you, Richie.
Yeah. Good afternoon to your pretty audience. First of all, why did we choose this topic and share it to you pretty audience? First of all, because we have to make the capacity to make the change and take action based on personal and from our classmates as students. We have noticed that this is a problematic that doesn't only affect the people, time, and other things, that also affects the planet Earth. And we choose this topic because we have the power of change. I mean, we can have a future like these ones in the video running in the background. And yeah, if we want a future like in the background, we need to take action ASAP. And that's what we're going to talk about now. So moving to the index, we have, first of all, why traffic is prejudicial, the CO2 emissions and what does this cause, also the overproduction of vehicles, the vial infrastructure, the junkyards pollution, also the soil degradation and what does this cause, and the end of all, the solutions we have to propose to you all pretty audience. So yeah, moving to the CO2 effects, Mao is going to explain it.
Thank you. The lessons we hope you can learn from what we are going to talk below is conscience. First of all, make conscience about the issue of traffic jam and its consequences. Earth damage also show all the damage the humans have done to the earth and the reality of things. Empathy, the earth is a planet where various living beings coexist. We have to take care of it since it's not only ours. New panorama. We want to give you all a new panorama and a new vision, so this you can see, start thinking in a very consequence of traffic jams. Yes, then I want you to present our solutions, and we want you to choose alternatives to save our planet.
So yeah, the theme we're gonna talk about is traffic jams and their effects upon Earth. When we talk about the negative effects of traffic jams, the first problem we think about is the CO2 emissions caused by cars and how does this affect the ozone layer and the planet Earth, generating greenhouse effects and planet heating. But yes, this is the most problematic issue, but that's not only the only problem that cars jams generate. Also, have we ever polluted in oil pollution of the water, like in the video in the background, all that oil polluting our water, also the deforestation just to build new traffic lanes, also the junkyard pollution that generates pollution to the air by heavy metals like lead and difficult to treat chemicals like lithium and not all. So yeah, that's the problems that also the traffic jams have. So moving to the CO2 emissions, Mao is going to explain it.
CO2 emissions. When we talk about contamination and air pollution, one of the things we think about first is that CO2 emissions comes from the cars, and that's right. For example, in Spain in 2019, the vehicle sector was responsible of 29% of the emissions in the country, and 99% came from the road. Same year in Colombia, the amount of 37% of these greenhouse effect gases came from the vehicle sector. Transport is also the second largest contributor to greenhouse gas effects emissions globally. This data is from 2018, a year after the COVID-19 was spread and the entire world was put in lockdown. In 2020, the emissions of CO2 went low, but back in 2023, they have recovered an increment. You can see this in the graph that it's in the presentation, and that drop is that information. But how does the traffic jam contribute? Well, it's simple. More time the cars are stuck, the CO2 level rises, and it makes more and more air pollution. This is the first and the most visible problem that the traffic jam has. It's one of the problematics everyone talks about and everyone focusing. But it's not only one. There's a lot of studies that shows how gases rises, and yeah, it's important. But there are more other problems we can solve. This is not the only one.
So yeah, moving to the other problematic that traffic jams have, we have the vehicle production and the overproduction of vehicles. As you can see in this graph, the vehicle life is getting shorter and shorter. I mean, cars right now doesn't longer like 30 years by promedium in USA. And that's very alarming because cars that are not to be designed to last eternal life but 30 years is pretty short time to generate cars and cars and cars and more cars that pollute the ambient, that are difficult to storage, are difficult to junkyard, and that's not necessary, because if people choose public transportation or other various of transportation, that will be solved, but that's not the case. This also generates an unnecessary extraction of a material that produces heating to the global earth, because the deforestation of zones just extract minerals for production of vehicles, just like lithium, steel, copper, and other materials. And also people say electric cars are the solution, but sadly, that's not the solution. You may ask why, if electric cars doesn't generate CO2 emissions, and yeah, that's true, but the electric cars also pollute more than a normal car, because lithium is a very, very risky material. If lithium touches water, it can be burned and it will be turned off until it consumes. Also, to extract lithium, as you can see in this timeline, also, first of all, we need to deforestate huge areas to extract a little bit of lithium. Also, then mining the lithium, the water and the soil is wasted. Have you know that to extract 1 ton of lithium, you need to waste 2 million liters of water? That's a lot. I mean, it's huge, and we cannot continue wasting that water. Also, the contamination. The cars of electric vehicles doesn't longer life of 15 years, 30 years, and then you have to buy now one or buy the new battery. And that's pretty contaminating, because batteries are very difficult to process, and this is contaminating a lot of the planet. So yeah. Moving to the junkyard pollution, you may say, where do all that cars that are trash go? And they go to the junkyard. It's a space of land that it's dedicated to almacenate, storage cars. And you can see in this image, the cars generate rust and heavy metals, just like lead, lithium, steel that contaminates our water. Also, the oil and other things that cars uses pollutes the water also. And also the space is wasted. A lot of space just to storage used cars is not necessary, basically, because if people have only one car or only have a car for 30 years, there will be less and less cars on that junkyards. And also the hazardous chemicals that cars have in these junkyards, just like batteries, lithium, copper, and all that, it's contaminating also the air, the water, and the soil, and making inhabitable. So yeah, moving to the bioinfrastructure, Mao is going to talk about it.
Thanks. Let's talk about bioinfrastructure. So, like we have mentioned, the population think buying a car can be the solution for more efficient transportation. But this is not only affect the earth by creating new cars. No, where does the cars are going to move in? Whoa, that's called bioinfrastructure. And it's all the roads and the streets pavement made that are constructed to facilitate mobilization, but this affects the same as the other problems we have talked about. Let's start with extraction and construction. We need material to build all these to build all this. Where do we extract it? Of course, from the earth. The extraction and transportation of materials like sand, gravel, and cement lead to habitat destruction. Manufacturing of asphalt and cement emits significant amounts of CO2 and other greenhouse gases, contributing to climate change. Basically, people buy more and more cars, and that make the traffic jam. We solve it by extending the vial infrastructure and building more roads and parking lots, losing soil for green areas. The same space that a train lane uses, it's more efficient than a traffic lane. This makes enormous quantities of loss and damage to the earth environment. Next, please. Then, let's talk about how the earth is affected by this, starting with landscape modification and habitat fragmentation. Like we can see in the image, an excavator is practically destroying the environment that was the house of a lot of animals. Road construction often requires this extensive land cleaning, leading to the destruction and the fragmentation of habitats. This disrupts ecological corridors, reducing the space's mobility and biodiversity. Excavation and earth movements during construction accelerate soil erosion, degrading land and affecting nearby ecosystems. Also, roads can disrupt natural water courses and drainage systems, increase of risk of flooding and alerting local hydrology. If we focus on the soil degradation, heavy traffic, for example, loads can use the soil substance of the formation of sinkholes, especially in areas with unstable geological formation. Vehicle movement compact the soil, reducing its water and absorption capacity. This affects all the surrounding vegetation, and it also increases surface runoff and the risk of erosion. Next one, please. Okay, let's see a little bit more this part of soil loss and degradation. As we have talked lately, the infrastructure of the roads have a huge impact on our planet Earth and contamination. But what happened with the new paths, the paths that we need to pass by, but there's no construction? The Earth is greatly affected by this, but let me explain you why. On paved roads built on the basis of soil compactation, the operation of vehicles on paved roads results in dust emissions. As a number of passing vehicles increases in the soil surface, it gradually decreases. This enhances emissions and reduces visibility, increasing health and environmental related issues, as well the risk of collisions. For example, there's a study dedicated to quantify the effect of the surface degradation on the dust emission from several types of vehicles traveling on different soils. The control of dust generated by human activities is major objective of air quality improvement. What that directly affects to the earth? Well, in this dust emission makes a huge soil degradation and reduces the soil abilities to support the plant growth. These soils can't retain water effectively, leading to more frequent floods. It loses the capacity to sustain plants, insects, and animals, reducing overall biodiversity, turning one productive land into barren deserts. Yes, it's very sad how this happens.
Okay, we're moving now to the summary. So we are going to present a video that we want you to watch. So pay attention, please.
Mutually assured destruction. Today, any nuclear country or terrorist is capable of inflicting damage on a massive scale with weapons of
environmental entropy. The polar ice caps aren't waiting for us to decide if climate change is real. Rising coastal waters, intensifying weather patterns, they're all punching our one-way ticket to dystopia. By definition, not perfect. Huxley's Brave New World, Bradbury's Fahrenheit 451, Orwell's 1984. Once considered fiction, these futuristic novels are actually happening right now, and they seem to be getting worse. Yes, Miss Newton.
Can we fix it?
Sorry?
I get things are bad, but what are we doing to fix it?
So yeah, what are we going to do to fix it? We have our solutions right here. The first of all, we cannot just disappear cars because they are now primarily a part of our life, just to move and all that. But we can make changes that benefit the environment, the humanity, and the life. Because if you didn't know, right now Mexico City is one of the top most congested cities in the world. For example, one citizen lost in amount 1,100 hours in the year. Have you imagined how that is? It's already like 46 days of the year. What could you be doing in 46 days in the year? Going to the family, exercising, other things. So yeah, traffic affects everyone and also the planet. So our solutions are, first of all, we need to stop using cars just for one person or just for short tracks or just for short travels, like going to the street corner. and we need to use or walking, the bicycles, maybe the public transportation, and that it's going to be the first stop of the CO2 emissions. Because if we just walk to the, I don't know, 5 minutes track, we will be making less and less CO2 emissions. And also if we have green areas like the corner in the bottom, like the bicycle instead of the traffic lane, it will be very healthy for the planet. Also, we have parks. We need to improve parks, and also the public transportation, like the train in the right corner. And also, what are we going to do with the cars? Electrics are not the solution. We have learned that today. So if we want to trans to electric, we also need to make new infrastructure, new chargers, new all of that. And that's it's going to be more contaminating than just staying in CO2 fuel emissions. But also CO2 fuel emissions contaminate a lot. So the solution for us is hybrid cars or hydrogen cars. Hydrogen cars are cars that are powered by hydrogen energy and also mixing the fuel. But if imagine if a car gives you 10 liters per kilometer, hydrogen cars could give you, I don't know, 150 kilometers per liter. And then that it's pretty good for the environment. Also, we would like to share, for example, carpooling, like in the top of the image. Sharing your car to move people, also the popular rides, give rides to the people just to go to the school and all that, and that is going to be pretty good to the ambient. So moving now to our conclusions. Yeah, the future of planet, it's upsetting. Yeah, the end of the world could be near. We don't know when, what or how, but this is our planet. Everyone's live here, so everyone's have the power of change. So how is it going to be the future? Like the left one, very green, very good, or the right one? Which future do we want? So yeah, that's the theme we presented today. Thank you for your attention, and here are our references.
Thank you very much.
Very much, Mau and Ricardo. That was an interesting topic too. So may I ask Ricardo, Mau, also Zaira and Daniel to please turn your cameras on, because we have some questions for you guys. Now we have to hurry up, but I have a question for you, Daniel. The question is this one. After the asteroid collided and almost all living beings were killed by the impact and the further consequences, which animals, or which, not animals, but which living forms survived? Very short, please.
Yeah, for example, the crocodiles, the black shark, and another space. This is the question, right? The animals survive of, yeah. Sharks, crocodiles, and another is birds, but it's only of the pelican.
Okay, thank you, Daniel.
Yes.
I think that we could also mention some insects, no, but and some other living forms, but well, yeah, we are running out of time. So thank you, Daniel. And now let's go to Zaira. Zaira, what specific suggestions would you set forward for teachers? Yes, because we know that teachers at any level, even from the postgraduate to the kindergarten, teachers can contribute a lot in order to solve problems or world issues. What would you suggest to teachers to do?
I suggest that during school, since kindergarten, teachers may show the problematic about not just the Permian, the Jurassic. They have to show us as actually, because and this is happening right now, and if the teachers just teach history about nature, about all the problems that happened, they don't understand that the problem is going to be in the future. I think that they must share about news about the new researches and the things that are happening, like advances, like other technology. that are developing the other people.
Thank you, Zaira. A lot to be talked about this topic, right? And now, Richie and Mauricio, there is a question coming from the YouTube chat, and the question says, which of the solutions you presented you think is the best one?
The best, well, we think the best could be the trains, because trains uses just a lane, a very thin lane, and can move a lot of people for long distances, and can be electrical, not polluting with lithium batteries, and also uses a direct wire to the AC current, and it's the best option that we think it's proposing right now. Also, the bicycle and the green areas are the best option we have.
Thank you, guys. Thank you to you all. And now we are going to continue. I am happy to introduce Tabata Muñoz Cepeda. She's also a student from Escuela Nacional Preparatoria Plantel 5, José Vasconcelos, and she is going to talk about how melting ice caps are transforming salinity. Welcome, Tabata. You have 15 minutes, please.
Thank you, teacher. Now I'm going to present my screen.
Yes, please do.
Good evening, everyone. My name is Tabata Muñoz, and I'm pleased to be here as a student of Prepa 5. And today I want to talk about something that is already reshaping our planet: how melting ice caps are transforming ocean salinity. This isn't just a scientific issue, it's something that affects all of us. Ocean salinity plays a crucial role in regulating climate, influencing marine ecosystems, and even shaping the weather patterns that impact our daily lives. But as global temperature rise, we're seeing massive changes that could alter the balance of our planet. To understand what's happening, let's first take a step back and explore why ocean salinity matters in the first place. The melting of polar ice caps is one of the biggest and most pressing environmental challenges we face today. As ice in Greenland and Antarctica continues to melt at record rates, enormous amounts of fresh water are being released into the ocean. This might not seem like a big deal at first, but the truth is it's causing major disruptions to ocean circulation, marine ecosystems, and even global climate stability. One of the most alarming consequences of this process is the weakening of the Atlantic Meridional Overturning Circulation, the AMOC. This is a major ocean current, a vital system of ocean currents responsible for redistributing heat all across the planet. But that's not all. These changes are also affecting marine biodiversity, increasing sea levels, and contributing to extreme weather events. The goal of this presentation is to look at how melting ice caps are changing the salt levels in our oceans and what that means for ocean currents, weather, and sea life. It's not just about numbers. These changes in salt levels show major shifts that affect everything, from rising sea levels to the health of marine ecosystems. Recent studies show that as polar ice continues to melt, the ocean mix of chemicals is changing. Sea levels are rising faster, and marine life is at greater risk. I know that we've all heard a lot about it, but I think it's still not that much talked about. Now, to fully grasp the impact of these shifts, we first need to understand what salinity is and why it is so important. When we talk about ocean salinity, we're referring to the amount of dissolved salts in seawater, usually measured in parts per thousand. On average, ocean water has a salinity of 35 parts per thousand, meaning that for every 1,000 grams of seawater, 35 grams consist of dissolved salts, mainly sodium chloride. However, salinity isn't uniform all across the ocean. It varies due to factors such like evaporation, precipitation, river discharge, ice formation, and melting. These changes in salinity play a crucial role in ocean density, which in turn drives massive circulation patterns like the thermaline circulation, also known as the global conveyor belt. This system helps distribute heat and nutrients around the world, playing a fundamental role in regulating Earth's climate. Now that we understand salinity, let's take a closer look at how melting ice caps are disrupting this balance. As polar ice melt, it introduces large volumes of fresh water into the ocean, lowering salinity levels and affecting marine life and ocean currents. This has profound consequences for biodiversity. particularly for species that depend on specific salinity levels to survive. For example, coral reefs. They're highly sensitive to salinity fluctuations. These ecosystems thrive in stable conditions, and any disruption, especially when combined with rising temperatures, can lead to coral bleaching. I know we've all seen these type of images, and they're really sad. But these ecosystems, this weakens coral structures, disrupts entire marine food webs, and threatens the livelihoods of millions of people who rely and depend on reefs for fishing and tourism. Beyond coral reefs, ocean freshening also affects phytoplankton productivity, which form the foundation of the marine food chain. There are these type of algae. If phytoplankton populations decline, fish stocks will follow, impacting global fisheries and food security. And it's not just marine life that are affected. Freshwater from ice melt is also contributing to rising sea levels, which leads to coastal flooding and habitat loss for countless species, now including humans. This brings us to one of the biggest concerns, how all of this affects ocean currents, particularly again, the AMOC. The Atlantic Meridional Overturning Circulation, the AMOC, is one of the most crucial components of our planet climate system. It moves warm, shallow waters from the tropics toward the North Atlantic, while cold, dense water sinks and returns southward. This cycle is essential for maintaining stable global temperatures. However, as Greenland's ice sheet melts, it releases massive amounts of freshwater into the North Atlantic. Because freshwater is less dense than salty seawater, it disrupts the sinking process that drives the AMOC. Scientists have already recorded a 50% of slowdown in the AMOC since the mid-20th century. If this continues, we could see more intense hurricanes and extreme storms. Due to excess heat trapping the ocean, harsher winters in Europe as warm ocean currents fail to reach northern regions and a shift in monsoon patterns, particularly affecting the intertropical convergence zone, leading to droughts in some regions and excessive rainfall in others, which disrupts this balance that we all have in the planet. If the AMOC were to collapse entirely, it would trigger its widespread disruptions in global weather, ocean circulation, and food production. Now let's talk about how all of this translates to real-world impacts on societies around the world. Rising sea levels, extreme weather, and changes in ocean circulation are already affecting millions of people, particularly those in coastal and island communities. The freshwater influx from melting ice is accelerating sea level rise. Global sea levels are increasing by 3.4 millimeters per year, with 2.9 millimeters per year directly caused by ice melt. This has serious consequences, including more frequent and severe coastal flooding, loss of farmland, and freshwater contamination in small island nations, and mass displacement of communities as rising waters force peoples to relocate. And while ocean salinity is decreasing in some areas, freshwater sources are becoming saltier due to human activities. Activities like road salt runoff, industrial waste, and seawater intrusion. It's kind of ironic because this creates a paradox. While some ecosystems are becoming too fresh, others are becoming too saline. So, what can we do about this? Well, we can stop ice from melting overnight. There are steps we can take to reduce the damage and adapt to the changes already happening. Some of the most important actions include cutting carbon emissions to slow ice melt and stabilize climate patterns, strengthening coastal management to protect vulnerable communities, investing in resilient infrastructure that can withstand rising sea levels, and enhancing scientific monitoring to better understand and predict future changes. I would like to share with you one of my favorite ones to reduce our emissions per person. It's to reduce our consumption on beef. The beef industry is one of the biggest contamination problems we have in the actuality. It's actually really funny how in some countries like Argentina and Brazil, there are some states or regions where the cow's populations are actually bigger than the human ones. So that clearly shows how our beef consumption is really big. Cows produce a gas, methane, which damage a lot of our atmosphere. That shows that we can do small actions at home that can still contribute to these type of problems. Also, by encouraging international cooperation, since climate change is a global problem, the ocean has all of us connected, and salinity shifts affect the entire planet. For my final thoughts, I would like to conclude saying that the melting of ice caps is already transforming ocean salinity, and the effects are being felt across the globe, from disrupting ocean currents to threatening marine life and displacing communities. The consequences are severe. However, by understanding these changes and taking action now, we can work towards solutions that protect both the oceans and the people who rely and depend on them. Thank you so much for your time. I hope this presentation has given you a clearer picture of why salinity is important. And thank you so much for your attention again.
Thanks to you, Tabata. It is quite disturbing to think about some of the topics that have been presented this evening. I mean, disturbing for those of us who are not specialized in this area of knowledge. And then we suddenly become conscious of how many things are affected by our lack of care of our planet. So, thank you, Tabata. And now I'm happy to introduce Hanna Tableros Farfán. She is also a student from Escuela Nacional Preparatoria número 5, José Vasconcelos. And she's going to present the topic, the deep ocean and climate change. Welcome, Hannah. You have 15 minutes. And after that, we are going to have at least one question for Tabata and another for you.
Okay. Ay. Ay. Espere, no, tengo problemas para compartir mi pantalla.
After Hannah's presentation, we will have the last presentation of this event by Diana Paola Tobar Zamora, who is also a student from Escuela Nacional Preparatoria, but Plantel 8. And she's also going to deal with another topic related to our planet. So Hannah, as soon as you are ready, please let us know. Or if you want to send your presentation and we can have it here and present it from here.
Just give me a second.
Okay. In the meantime, I will read a very short introduction to Hannah's topic. In her summary, she says, the deep ocean is a vital ecosystem for climate stability and global biodiversity. However, climate change and human activities are putting these ecosystems at risk before we can fully understand their significance. Exploring, understanding, and protecting the deep ocean is not just a scientific endeavor. It is an urgent necessity for the health of our planet. International cooperation and the development of sustainable technologies are essential to ensure that the lights in the darkness of the deep ocean continue to shine into the future. That is a beautiful thought, Hannah. Hannah, si quieres, mándanos tu presentación y podemos dar lugar. Ya tenemos aquí a Diana Paola Tobar. Podemos darle lugar a Diana y después de Diana presentas, Hannah, para que tengas unos minutos más para resolver el problema. Entonces, voy a permitirme presentar a Diana Paola Tobar Zamora del plantel 8 de la Escuela Nacional Preparatoria. Como les decía hace unos momentos, ella va a presentar el tema afectación del dióxido de carbono en la lavanda. Bienvenida, Diana Paola, tienes 15 minutos y después quédate con nosotros para algunas preguntas. Puedes empezar, Diana, por favor. Sí, Diana, puedes enviar tu presentación, si no la puedes poner tú y nosotros la presentamos.
¿Ya vas? Voy, ahorita la comienzo a presentar.
Ah, bien, correcto.
¿Me pueden habilitar la cámara, por favor? Es que no puedo.
Adelante, Diana, bienvenida. 15 minutos a partir de este momento.
Sí, muchas gracias. Bueno, buenas tardes. Mi nombre es Diana Paola Tobar Zamora. Soy alumna de la Escuela Nacional Preparatoria número 8, Miguel Schulz, del grupo 656, y pues quiero presentarles mi experimento, que es la afectación del CO2 en la lavanda. Permítame. ¿Cómo le recorro? Que no me deja. Ya, gracias. Primero la introducción. El aumento del CO2 en la atmósfera está relacionado con el cambio climático y pues las plantas absorben este gas mediante el proceso de la fotosíntesis, la cual es muy sensible al incremento de la temperatura y del CO2. También tenemos que la lavanda es una planta semiarbustiva que atrae a polinizadores y que es, bueno, que realiza fotosíntesis y pues recibe sí, como que los niveles de CO2 aumentan su capacidad de germinación y de crecimiento. Después tenemos nuestro problema, el cual es que durante el periodo de 2001 a 2020, la temperatura global aumentó 1.1 grados centígrados debido al incremento en la concentración de CO2 y otros gases de efecto invernadero. Y pues se estima que para finales del siglo XXI, el aumento pudiera alcanzar o puede alcanzar los 4.8 grados centígrados. Dado que la fotosíntesis es altamente sensible al cambio climático, es fundamental que evaluemos si la exposición prolongada de niveles de gas o en este caso, la temperatura, resultan beneficiosos o perjudiciales para el crecimiento de la lavanda. Nuestro objetivo fue construir un sistema cerrado con efecto invernadero natural y el otro un sistema igual cerrado, pero con un efecto invernadero amplificado por el aumento de CO2 en el aire. También fue determinar el objetivo combinado del aumento de CO2 y de la temperatura en el porcentaje de germinación y de semillas de la lavandula angustifolia. Aquí también analizamos el impacto combinado de la alta concentración de CO2 y la temperatura en el crecimiento de la lavanda o la lavandula angustifolia. Nos basamos en una proyección hacia el año 2100. Nuestra hipótesis fue que el incremento en la concentración de CO2 en el aire produciría un efecto invernadero amplificado y la combinación de estos factores resultaría en un cambio en el porcentaje de germinación y las etapas de crecimiento de la lavanda o lavandula angustifolia. La metodología fueron dos sistemas cerrados, un sistema de control donde tenía 423 partes por millón de CO2 y se plantaron 5 semillas, y el segundo es un sistema experimental donde tenía 801.3 partes por millón y de igual manera se sembraron 5 semillas. Nuestra variable independiente en este caso sería la concentración de CO2, ya que nosotros lo introdujimos, y la variable dependiente sería la temperatura, el porcentaje de germinación, el número de hojas o la longitud de los tallos. Los resultados obtenidos fueron los siguientes. En el porcentaje de germinación, en el sistema de control, que es del año actual, la germinación fue de un 80%, como se puede mostrar en la gráfica, y pues las semillas que no germinaron solo fueron el 20%. El segundo es el sistema experimental, donde añadimos, donde añadimos el CO2. Y pues esto lo hicimos con el año 2100, en el cual solo tuvimos 40% de semillas germinadas y pues el otro 60% sin germinar. Pues es como una disminución importante, pues casi es la mitad. Y pues aquí lo que se nos muestra es que el aumento de este gas y la temperatura redujo los porcentajes de germinación, lo que da menor posibilidad de supervivencia y pues es importante darnos cuenta de eso. Luego tenemos la longitud de los tallos. Como podemos ver, lo medimos en centímetros y pues en los días que se llevó. En el sistema de control, este es el sistema de control y pues el crecimiento de los tallos podemos ver que es pues de un tamaño chico. Y pues en 78 días nosotros solo pudimos obtener el dato de que llegó a menos de 1 centímetro de altura. Por el contrario, en el sistema experimental, que aquí como pueden ver, lo enriquecimos con CO2 y tiene tienen mayor longitud los tallos, pues se ve incluso en la diferencia que son de 7 centímetros en 78 días. Y pues esto nos indica que el CO2 elevado y la temperatura favorecen el crecimiento de los tallos. Luego hablamos del crecimiento de las hojas, el cual lo medimos por número de hojas y de igual manera número de días. El sistema de control mostró que el número de hojas era menor que en el sistema experimental, pues eran más hojas, al igual que los tallos eran más grandes. Esto nos dice que o nos puede decir que el incremento del CO2 y la temperatura igual favorecerían a la aparición de mayor número de hojas. Y ya por último, pues tendría las conclusiones que serían que el sistema experimental con efecto invernadero amplificado presenta un incremento en la temperatura de 1 grado centígrado, a 1 grado Celsius, con respecto al del sistema con control de efecto invernadero natural. La siguiente sería que después de 78 días, la tasa de germinación de las semillas de lavanda en el sistema de control, en comparación con el sistema experimental, disminuyó, no, perdón, en el sistema con control tuvimos más germinación que en el sistema experimental, y esto nos dice que puede disminuir la posibilidad de supervivencia de las plantas, ya que pues a mayor CO2 tuvimos menos germinación. Y esto podría ser importante, pues en algunos años, como lo vemos ahí en el 2100, podría llegar a afectar a la ecología, incluyendo los polinizadores y pues también la seguridad alimentaria. Y pues por último, a pesar de la disminución en la germinación, el aumento de temperatura también favoreció a un mejor desarrollo en los tallos y en las hojas. Esto gracias a la fotosíntesis y a la producción de la biomasa. Y pues eso sería todo. Eh, Aquí tenemos mis referencias y por si querían consultarlas, y eso es todo. Gracias.
Muchas gracias, Diana. Y bueno, ahora vamos a dejar a Hanna Tableros Farfán que cierre este evento con la última presentación. Ella tuvo algunos problemas técnicos hace un momento, pero ya quedaron resueltos. Entonces, Hannah, adelante con tu tema. The Deep
Yes.
Ocean and Climate Change. Thank you very much for being back, Hannah, and we are ready to listen to you. You have 15 minutes, please.
Yes, thank you. And good afternoon, everyone. My name is Hannah Tolero Sarafan, and today we'll explore the deep ocean, its importance, and the dangers it faces due to climate change. I chose this topic because ocean acidification caught my attention, and is a silent but growing threat to marine life. This topic is often overlooked, yet it has several consequences for the ocean and ultimately for us. And before today, I would like to ask you a question. Had you heard about ocean acidification? And if not, why do you think this issue isn't widely discussed? But what is the deep ocean? And the deep ocean begins at 200 meters below the surface, where sunlight no longer reaches. It covers 95% of the ocean's volume and is home to extreme conditions, yet it harbors incredible biodiversity. Here's an scheme of the deep ocean, and it reaches the 11,000 meters. Then the importance of the deep ocean. The deep ocean regulates Earth's climate, absorbs carbon dioxide and produces oxygen, and sustains marine life. Without it, our planet's climate balance will collapse. And we have the climate change and the ocean acidification and its effects on the ocean. Climate change is disrupting deep sea ecosystem. Rising temperatures, decreasing oxygen levels, and ocean acidification threaten species that have adapted to stable conditions for millions of years. But what is ocean acidification? It occurs when carbon dioxide from the atmosphere dissolves into sea water, forming carbonic acid, and this process lowers the ocean's pH, making it more acidic. Since the Industrial Revolution, ocean pH has dropped from 8.2 to 8.1, and it is expected to decrease even further by 2100. And now the biological impact for the species we have in this ecosystem. First, we have the difficulty forming skeletons and shells, and the acidification reduces carbonate availability, weakening corals, mollusks, sea urchins, and crustaceans. And there's also physiological stress in fishes, and the higher acidity affects fish nervous systems, making them more vulnerable to predators and disrupting their survival instincts. Um, there's also impact on plankton populations. The phytoplankton is the foundation of the marine food chain, and its decline affects the entire ecosystem. And there's also reproductive challenge. Some species struggle to reproduce, impacting biodiversity and the stability of marine populations. And in the first diagram, we can see how both the planktons on the ocean and the plants on the land contribute to convert carbon dioxide into oxygen. And a fact that many people know is that the ocean, by being much bigger than the land, it contributes more to this oxygen production. And in the right, we have a graphic that is the percent of marine species collapse from 1950 to 2003, and a prediction to the next 25 years. And this is the global fisheries data, and this is the prediction. And there's also impact on the food chain. Phytoplankton is the base of the marine food web. If it declines due to acidification, entire ecosystems, including commercial fisheries, can be affected. And the zooplankton, which feeds on the phytoplankton, will also decline, reducing food availability for small fish. As a result, predator species like tuna, sharks, and whales will face food shortages, disrupting the entire marine food web. But the deep ocean is also affected by human destructive activities. And while climate change is a major threat to the deep ocean, human activities are accelerating its extraction. The most damaging activities include deep sea trawling, mining, and pollution. And we have the importance of the coral reefs. The coral reefs support 25% of marine life, protect coastlines, and sustain fisheries. And without them, biodiversity collapses. And other question, what will happen if the coral reefs disappeared? And how will this affect humans and marine life? Well, there is a direct impact on us. The deep sea ecosystems depend on nutrients from surface waters, but climate change is reducing the supply. At the same time, overfishing and habitat destruction are threatening fish populations. Fortunately, new exploration technologies like autonomous submarines and genetic research are helping scientists better understand and protect these ecosystems. There's also conservation efforts, and we have to apply urgent conservation measures. The marine we have to establish marine protected areas and stricter fishing regulations and conservation policies are key to preserving deep sea ecosystems. And my conclusion and a summary of my presentation is that the deep sea plays a vital role in Earth's climate, food systems, and biodiversity. However, ocean acidification, rising temperatures, and human activities are threatening its stability. If we do not act now, the consequences could be irreversible. But how can this relate to us? Um, Even the deep ocean seems distant, it affects our daily lives. The oxygen we breathe, the climate we experience, and the seafood we eat all depend on the healthy ocean. And understanding this challenge helps us make informed decisions about protecting marine life and ecosystems. And what can we do to the future? To protect the ocean, we must take action now. Governments and industries must enforce regulation to prevent overfishing and pollution. As individuals, we can support conservation efforts by reducing our plastic use, and choosing sustainable seafood, and advocating for marine protection policies. And the future of the ocean depends on the choices we make today. And I invite you to ask me if you have doubts or questions. And thank you for hearing me.
Thanks to you, Hannah. And please stay with your camera on. And I will like to ask Guadalupe, Diana, and also Tabata to please turn your cameras on. We are going to have a question for each one of you. There are many, but we are going to have only one. So, yeah, please, Tabata, you were talking about the negative consequences of modifying or affecting the salinity of seawater. And you mentioned especially or more specifically those negative consequences upon climate, upon weather. The question is, would there be any consequences for animals others than those that live in the sea?
Yeah, I think the answer is yes, teacher. As also the climate is changing, the heat can get colder, or it can increment the heat in our planet. For example, polar bears, we're seeing that it's affecting directly and indirectly to them. There are also species that, for example, they thrive on monsoon patterns. Monsoon are rains that fall, and without it, I think that there will be a lot of species, like, for example, that live in the jungle, that would not thrive in very stable conditions.
Thanks a lot, Tabata, for your answer. And there's another question. Esta pregunta es para Diana y la hacemos en español porque ella presentó en español. ¿Cómo calcularon la cantidad de CO2 en cada sistema?
Pues la del sistema de control, solo pues como se cerró la botella, es la del año 2024, y la del experimental la hicimos con, bueno, como que no tuvimos tanta conciencia del cambio climático, que pues en la actualidad eso ha afectado, y nosotros lo que quisimos nada más es como, pues, no sé, como dar sí, explicar que en un futuro va a haber más concentración de este gas, y pues eso es lo que quisimos hacer nada más. O sea, no lo hicimos tan exacto, solo quisimos dar a entender que en un futuro va a haber mayor concentración de este gas.
Muchas gracias, Diana. Hay más preguntas, pero nos vamos a quedar con esta porque estamos ya cerrando. Y para Hannah, there's a question. Well, there are many, but there's only one question for you, Hannah. The question comes from Marcos Legaria, and he asks, how long have the oceans been acidifying?
Since the Industrial Revolution, there is an increment of the pH of the oceans in general, but yes, it's since the Industrial Revolution.
Thank you very much, Hannah. Y con esto terminamos con las presentaciones de esta tarde y también con todo el evento. Y para hacer la clausura, doy la palabra a la doctora Susana Alicia Alanís Álvarez del Instituto de Geociencias para que ella nos haga el favor de hacer el cierre de este evento que estuvo a su cargo y en el cual coordinó una gran cantidad de ponentes, dos equipos de dos entidades distintas y una serie de invitados de otras universidades también. Entonces, bienvenida, doctora Susana Alanís.
Gracias.
Palabra para que nos haga el favor de hacer la clausura.
Cosme tiene que habilitar el video. Ah, ya. Gracias. Bueno, antes que nada, quiero agradecerles a todos ustedes su participación. Realmente enriquecieron muchísimo el programa. Estoy muy contenta. La verdad es el primer coloquio internacional que teníamos, y en el que estábamos involucrados en la Escuela Nacional Preparatoria, el Instituto de Geociencias en la organización. Y la respuesta de la gente fue muy buena. Hubo estupendas ponencias de muy alta calidad, pudimos convivir de distintas instituciones educativas del país y la verdad no puedo estar más que muy agradecida con todos los que participaron. Quiero agradecer en especial al comité organizador. Aquí está Alan, Ilse y Rodrigo, pero también estaba Alexis y Katy y el grupo de técnico de la Escuela Nacional Preparatoria número 5 que transmitió. Todas las transmisiones fueron muy buenas. La verdad hubo muy pocas ausencias de ponencias y bueno, yo espero que ustedes los hayan disfrutado igual que nosotros. Yadira, ¿quieres decir unas palabras?
Agradezco mucho la oportunidad. Bueno, nosotros hemos disfrutado muchísimo el haber podido convivir con los diferentes niveles. Creo que este evento tiene ese gran valor de haber reunido bajo la invitación de la doctora Susana Alanís, investigadores de diferentes entidades, profesores y estudiantes del posgrado, de la licenciatura y del bachillerato. Esta convivencia ha resultado muy rica para todos, a unos de una forma y a otros de otra. Y bueno, pues también para nosotros como docentes tener a los estudiantes es siempre muy gratificante el poder verlos crecer, desarrollarse, incursionar en eventos más allá del aula y en todo ello, lo que estamos buscando es ser mejores seres humanos, poder contribuir unos con otros. Y mil gracias, doctora Susana, muchas gracias a la UNAM, nuestra muy querida alma mater. Muchas gracias a la Escuela Nacional Preparatoria por tenernos desde hace tantos años. Muchas gracias al Instituto de Geociencias. Gracias a todos los equipos que estuvieron participando en esto. Y bueno, pues esperamos vernos pronto en una próxima ocasión. Doctora Susana, no sé si tendrá por allí ya una invitación lista para todos.
Bueno, claro que sí, por supuesto. Este coloquio se organizó gracias a la continua publicación de la revista Enseñanza y Comunicación de las Geociencias. Está hecha para todos los niveles, desde educación básica hasta posgrado. Muchos investigadores han publicado ahí. Bueno, tengo que decir que de la Facultad de Ingeniería estuvieron muy interesados en esta revista, porque si me preguntan a mí, en educación, la educación ha avanzado muchísimo. Ya quisiera uno haber tenido un coloquio de estos donde poder foguearse, ¿no? Y presentar tan estupendos trabajos como ustedes. Y hay muchos trabajos, desde estudiantes hasta directores de facultades que han publicado en esta. Yo creo que hay 2 o 3 revistas en el mundo de enseñanza de las geociencias. Así que, bueno, quiero invitarlos a ustedes a que presenten sus trabajos si quieren en la revista, a que la lean, a que la distribuyan, a la que vean por lo menos el índice o además se animen a publicar. Rodrigo, ¿quieres decir algo?
Nada, pues nada más me uno a las felicitaciones a todas y todos los que participaron y agradecerles. Y pues estuvo muy interesante. Todavía me quedan videos en YouTube por ver, porque hay mucho material. Yo quería estar en las 2 aulas, pero físicamente era imposible. Entonces todavía nos queda mucho por trabajar, ver y seguir compartiendo para, pues sí, mejorar métodos, enseñanzas, aprendizajes y bueno, muchas cosas que vimos en el coloquio. Gracias a todas y todos y al comité que estuvo excelente. Gracias, saludos.
Gracias a Katy y a Alan. Realmente qué impresionante. Generalmente no pasa todo así tan bien como aquí lo vimos, ¿eh? Katy, ¿quieres decir unas palabras de una vez? Aunque sea, nos vemos
Bueno,
pronto.
tal cual. Pues yo nada más agradecer realmente el trabajo que entre todos se ha hecho, porque realmente eso se logra con un trabajo arduo, ¿no? Que involucra muchas cosas, ¿no? Sabemos que estuvimos ahí con ciertas cuestiones, de repente sustos detrás en la parte técnica, angustia antes de iniciar el coloquio, porque retomar la parte en línea no es sencilla, ¿no? Hay que volver a ubicar cómo están todos los comandos, que si proyectamos, si no proyectamos, que si se escuchan ruidos, pero todo eso es parte de, y al final uno termina muy contento porque ve el producto de todo ello. Ahorita aprovechando que están Tabata y Hanna y esta Diana, ¿no? Como representantes de los estudiantes de bachillerato, la verdad es que muy orgullosa de que estén, ¿no? De que estén aquí porque efectivamente desde aquí vamos dando pautas y varias de las cosas que mostraron nuestros ponentes a nivel incluso de posgrado era trabajando con los niños de primaria, ¿no? Y eso creo que no lo tenemos que perder de vista. Es que todo lo que hacemos se proyecte más allá de un salón de clases al nivel al que estemos trabajando y por eso creo que esto ha sido muy enriquecedor. Vemos gente que está ya en otras áreas y está también trabajando para estos niveles académicos. Eso es muy gratificante. Otros que van sobre la parte ambiental y todo esto nos da mucho. Agradezco realmente el trabajo, ¿no? De Adriana en la parte técnica, en la parte de moderación, Alan que siempre estuvo ahí al pendiente, Rodrigo sé que también estaba ahí como loco en la parte técnica viendo lo de YouTube y lo de Facebook, ¿no? Ilse, que bueno, ¿no? Impresionante en toda la parte, ¿no? De estar viendo los formatos, trabajaba y ponía y lo teníamos en un minutito prácticamente todo. Vaya, de verdad agradezco mucho todo esto porque de verdad es un trabajo arduo. Y bueno, ¿qué pues puedo decir de ustedes, Susana y Yadira? Unas líderes en todo lo que llevan a cabo, unas personas que nos enseñan a seguir hacia adelante y que nos impulsan a los que estamos ahí, ¿no? De apoyo. Así que muchísimas gracias, ¿no? Nada más.
Bueno, nada más yo quisiera terminar esto porque ya casi me voy. Esto inició con una visita de los maestros de la Escuela Nacional Preparatoria al Centro de Geociencias en Juriquilla. Inició en un programa que tenía la UNAM de visitas de los maestros a los centros de educación, se organizó, fueron y esta Yadira me dijo, oye, ¿no sabes tú de un material? Porque estoy organizando un grupo de ciencia y lengua. ¿No tienen material como que podamos usar para traducir? Le dije, sí. Y ya así empezamos a traducir unos libros, luego siguió un diplomado, Yadira me dijo que pusiera un diplomado, hicimos un diplomado y luego la revista y luego este coloquio. ¿Qué más puede uno pedir que una colaboración entre personas de muy, muy alta calidad profesional, ¿no? Que se lleven a cabo bien. Bueno, no los entretenemos más. ¿Mm? Ok, bueno, entonces damos por terminada, por clausurada este coloquio.
Tomamos una foto final, perdón, doctora.
Así, vamos a sacar una foto final. Y damos por terminado este coloquio. Hoy a las 19:35 del día 20 de marzo. Nos vemos pronto. Si se quieren quedar, los organizadores, déjame decirle a este Alex que se quede, pero